And welcome to the APAC, the Asia Pacific section of our incredible conference, JDConf. Now, if you didn't watch the first section, which was the Americas, you can go back and watch the on-demand recordings. They're going to be up, if not already soon, they're going to be up very soon. And we've got a incredible lineup packed for you. And don't worry, there is also another section after this with Europe, with my colleague Sandra. So what do we have in store for you today? Remember, all of these are going to be recorded, so definitely go in, and if you've registered, you'll be able to get access to all of that. And we're streaming live. So we're first going to go through, and the theme of the day is AI. So kind of looking at these sessions, the first session, we're going to go building LLM maps with Java and LangChain for J and Jakarta EE. Then we're going to go through to AI for Java developers. We're going to have the state of AI and large-scale automated refactoring. Whoa! Then Modernize Spring apps using your favorite tools and techniques. Modernize Java apps using GitHub Copilot Upgrade Assistant for Java. Spring Quarkus, Tomcat, JBoss, EAP, Hyperscale, PaaS for any Java app. And then finally, Paketo Buildpacks, the best way to build Java container images, question mark? Oh, I want to go ask some questions there. So I'll be your host in these sessions, but I want to remind you also, please go and take your camera out, take the Java learning opportunities today, go aka.ms/Java learning skilling. And there's so many great opportunities to learn for that. Some of that material I even made myself. So I get some real kudos if you go in that. So next, I want to remind you, obviously, about the code of conduct. We have a forum online on YouTube. that you can go in and pop your questions there. We got people standing by to make sure we can answer those questions. You want to reach out to the host, myself, Rory, or you want to reach out to the speakers, please go in there, pop your questions, be kind, be generous, and be relevant to the speakers though. And it will be a great opportunity for you to go through and meet and speak to these individuals though. So the first speaker we've got, the speakers, are Balzer and also Saeed from DNA Stack and Red Hat. And they're going to be speaking on LLM apps with LangChain4j and Jakarta EE. And if you don't know LangChain4j, it's an incredible framework that allows you to, take the pain out of AI. So I want to bring them over into here, and then we can have a nice little chit chat on what they're going to be doing. So until they get onto the screen here, I want to remind you let's go into here to take that Java Learn skilling there. Welcome. Oh, what a lovely transition. Hey, do you see that? Just went quack, quack, quack. I don't have to do anything. Thank you, Reactor team, for being so on par here. And now we've got some incredible talks here. And I love LangChain because it really obfuscates the need to manage the life cycle of a lot of your apps. But how are you going to do this with Jakarta EE? I don't know. So I'm very keen to understand how are you going to do that, though. So welcome.
Well, thank you for letting us speak about this. Obviously, yes, the topic is interesting. LangChain4j, which is sort of like de facto for building apps with AI and Java, right? And why we took Jakarta, we wanted to basically try it out ourselves and see, what do we learn, and that's what we're here to share with you, is exactly what we learned. So me and Basler together. Perhaps Basler, you want to quickly introduce yourself as well?
Hey, I'm Basler. I'm a software developer, and I'm also a Java champion, and currently working with the AI and LLM. So yeah, we'll enjoy. I'll show you some demo. Looking forward to it.
Cool, awesome. And my name is Sayed Shaf. I am a developer advocate at Red Hat. Yeah, I work with Java, large language models, you name it. So that's what I do. And what we've done is, like, roughly about a couple of months ago, me and Basler, we both started to kind of dig in deep into, okay, what is LangChain4j? How does it work? And then we started to put things together. So, Jakarta EE is just one opinion of it. There's tons of other things you can do with Quarkus, with Spring, with Micronaut, etc. So don't think that this is the only option. But I think what we want out of this session is for you to learn a little bit about large language models, and also learn that Java is the best language for it, right? So hopefully we can give you some of that. I'll speak for a little while. I have about 300 slides for you, and then
okay, I'm gonna drop off now, you guys, and have good luck, and I'll meet you at the end of your presentation.
Awesome. Thanks, Rory. Thanks for that. So I have about 300 slides for you. Like I said, not really, but we're just going to go through a bit of presentation here, and then Basler is going to take over, and most of the time, hopefully, we'll spend with demonstration. So why large language models in general? If we look at systems, you work with enterprise systems today. You have processes around it. You want to do certain things with the data. Data can be structured, unstructured, but data is specific in an entire context of itself. And it doesn't speak natural language. You cannot start to converse with it in natural language either. So it's a little bit more rigid when it comes to that. It does lack a bit of sentiment sometimes, but it definitely has context and a lot of it, right? So how can we bring those two things together? It's kind of important, and also makes better experience. So generating content can be costly. It can be hard in terms of how you create new applications, bring them together. All of that needs a lot of love and care. And when we build application, they take time. They just don't happen over just a couple of minutes, right? Maybe these days with some vibe coding, if you have it, might be able to do something out of it. But yes, creating systems is not that simple. users needs to be kept in mind, etc. But then if we have the possibility to add data to something like a large language model and be able to ask questions, interesting questions from pure natural language, it kind of makes things a bit more interesting for us. Another aspect is also the rapid data growth, right? So there's a lot of data growth that happens when it comes to IoT systems, edge devices, even from systems where we collect metrics, observation data, etc. There's a lot of data growth these days, and data is interesting, right? So why not make use of it, and why not use something like which can actually process on natural language and give us some meaningful insights into the data we have. So models, artificial intelligence kind of makes sense. Another thing is obviously rising expectations. Like today, you, for example, call for something that went wrong. It's a support ticket. Customer, let's say you created a support ticket, you had an airline flight, you wanted to reschedule, etc. And it gets harder and harder because their systems are rigid, processes are rigid. You don't get a lot of information out of it. Another example is like if you're searching your bank or your transactions, again, while searching them, you need to go through a rigid system which just has filters, etc. What if you were just able to quickly search it through natural language, etc. as well? So there's some interesting use cases that you might want to look at, right? So let's take a look at quickly around what the journey of large language models has been. If you have taken a course in expert system back in the days, then you've been here for a long time, right? They were quite hard. They use a lot of data that was authored with rules, etc., but that was very rigid. It was not so easy to train systems back then. But then, machine learning, deep learning came in there, and that kind of changed the way how we program the neurons or tensors or whatever you want to call them, and can actually have learning that was supervised or unsupervised. So basically train the system in a way that it can effectively make certain decisions and learn from them as it went forward as well. And in the recent years, what we've seen is the foundational models, which basically come out of a lot of data, labeling that data, putting that data into these systems and creating something which is interesting for us from a natural language perspective as well. The other aspects of large language model is what we've heard about, for example, is the transformer architecture, and that kind of brings it to a more interesting area because systems like GB3, I believe, was trained around 300 billion websites, etc., and it of words, and that's a lot of data. Common crawl data set is even bigger, and all of those data sets brought together give you a lot of information to basically use things like we can do summarization, generate specific text, and some of the interesting cases like generating poetry, etc., stories. But how about we can use them to actually do more deduction out of the systems and create more meaningful content as well. The way large language model works, they use tokens, and tokens sort of kind of describe the different layers of how large language models are trained. For example, if we were taking a simple word as unpredictability, you would see that it could actually be tokenized into 3 different arrays as well. And that is important because that's how the large language model reacts. And sometimes we might not get the answer when we look at a RAG solution, and we're going to demo some of the RAG solution today as well. So things could actually not make sense, but then they also make sense when you bring them into a larger chunk, etc. All of that plays around with these numeric values that you see. Another thing that you see is when you send a request to a large language model, it is also going through tokens and coming back in tokens as well. So it's also a mechanism of how you're consuming the large language model, or maybe in terms of cost and pricing as well. Another aspect of large language models is they are not usually very accurate. So do not mix accuracy with truth. And here, for example, you see an amazing photograph, but that photograph is not completely correct, right? And this can happen. And large language models have the problem that they will hallucinate when they don't have the data that you actually are using. So this can get tricky, and how do we actually work with that is also interesting and something to work with, and that's where approaches like RAG or some of those other approaches come, but they do not fulfill that. However, there are things like guardrails or privacy, etc. But just putting some thought there for you, that do not think this is a silver bullet that's going to give you an answer for everything. It's going to fail, and the most important thing is when it fails, how do you deal with it? The other thing is that truth is obviously is not continuous. We don't say things like, hey, we saved 6.5 lives. We don't save 6.5 lives. We save 6 lives or 7 lives. And I think that's the important differentiation between how large language model works in terms of how the real life works as well. And that's also an important factor to think about when we start to look at large language models. A lot of words, even I said a lot of these words in maybe a speed record time here, but basically, when we look at large language models and when we start to take our first steps, we would see this, that there's a lot of words like embeddings, like attenuation, transformers, etc. All of these things and all these different models that are in there, that can confuse you. So hopefully from this session and from the source, etc., that we share with you, you're able to sort of get started and start to learn about large language models in a much more easier way. The tool that we also had in our title was LangChain4j, and LangChain4j gives us the possibility to integrate with large language models, gives us the possibility to RAG tools. If you want to write MCP, if you've heard about Model Context Protocol recently, we can use LangChain4j as well. So it's a really good and nice framework for us to work in the Java ecosystem to integrate with large language models. And at this point, I'm gonna take a little pause, and I'm gonna let Basler share his screen so he can demonstrate what we are looking at and how can we actually create smart applications in Java using large language models. So Basler, over to you.
Basler, I am so sorry. You are on mute. I am so sorry. We still cannot hear you.
Can you hear me?
There
now?
we go. Thank you.
No, I'm so sorry again. All right, moving on. So we have prepared plenty of demos for this tool with the LangChain4j and the Jakarta EE, but due to time constraint, obviously we'll not be able to show you all the demo. So we're going to pick a few, and this is how we started. Basically, there is a Start Jakarta EE project over here where you can basically choose your favorite platforms, versions, and Java environment, and then you can click over here the generate button. It basically give you a structure, and then on that structure you can put your own code. So that's how we started, and that's how we build our demo. So this is the first one. Basically over here, as you can see in the POM, we have some dependency mostly related to Jakarta EE, and then we have these two tools, which is LangChain4j. One is for OpenAI and one is for the core. So these are the two dependencies we're dependent on, and all the communications with the model, for example, OpenAI or some other models that are out there, it abstract everything over here. So as a developer, we can write something like this. So we have a, over here, we have a class called OpenAI chat model. It's basically an abstraction, and then there is a builder button. And using this builder button, we can provide additional parameters, which is you can check later. But this is how we basically create a chat model, and then we can send text to it. So over here, as you can see, chat model, there is a method called generated. We are sending messages, and it will respond the messages. So in this project, we have a WebSocket basically that's talk to the UI, and we have a nice UI over here that we can show you. So what it does is basically when we write something, it communicates with the WebSocket and send the message to that particular class that I showed you, right? And then it's sent back to us. That's all it does. So it's a little UI that we wanted to show you. So on top of that, we basically started building some other interesting aspect of this LangChain. For example, by default, all LLMs are fire and forget. It use fire and forget strategy. It doesn't have memory, right? But when you are discussing with having a conversation with the user, you need to preserve the context of previous conversation. Otherwise, the LLM will not have the context to respond properly. So all those things are added on top of one by one. So we have a 9-step project over here that we're going to share with you, the Git repository, but we'll probably not show you all, obviously time constraint. So there also we can customize the prompt. For example, you can provide the system messages. We have a few over here. For example, if we want to use a prompt like that, we can do something like this. It's called AI services. We can provide our specific prompt, so the idea is we can specify how we want to get response, and then we can send a message that this is what we want. So if we want to specify how part, we can specify using this prompt. As you can see, it's simple, and we have just 2 annotation over here: system message and then user message, which is going to pass through the users. So all of those things, but I'm also going to keep this particular one, and I'm going to directly go ahead and start with another interesting tool idea, which is called tool. For example, if I go over here, and if I ask the chat, this is a chat interface, right? If I ask like, hey, do you know the latest stock exchange information, it will probably not be able to answer that, because as you can see, it says I'm unable to provide the real-time stock access information or financial data. So, but what if we want to have those things? Something like, let's say I want to browse a certain website. For example, if I ask to browse my personal website, which is buzzview.ca, by default LLM would probably not be able to do it, but we can add some sort of function calling on top of it, and it can do that. So that's what I'm going to show you, how we can simplify that. As you can see, it's returned that I have written this article. That was my last article. So how did we accomplish that? We have a tool over here. This is pretty simple. We can just specify a annotation over here, which is tool, and we can provide the description, what is tool supposed to do, and extract the information, and we can put our information logic over here. And how do we put this to our LangChain service? So I already showed you. We can create a chat model using this builder button, and then over here we have another abstraction which is called AI services, and over there we can provide all these tools that we want to use. For example, over here I have 3 tools. One is this web tools that I already showed you, and the other one is a Java compiler. So basically what it does is it can take the Java source code and then compile it, and then run it and share the output. So this is I wanted to do something fun. So that's the tool that I used over here. As you can see, I specified the tool over here and provided the context. For example, execute the provided bytecode directory. So if I provide a bytecode directory, it can extract this information and compile it. And also there is another one, which is Java P command. You can disassemble a Java code using this. So I'm not gonna explain all these codes. You can see the code from the repository, which I'm gonna show you. But let's show you a demo quickly. So what I'm gonna do is over here. I'm going to write just, hey, can you write a simple sorting algorithm with Java? And let's see if it can. It's fairly easy. It can, in fact, write the Java code. But the challenging part is if you ask our Chat GPT website and you put a source code there and say, and if you ask it to compile it, it will not be able to compile it. But this tool with this supports, we can do that. So I can ask it, hey, can you compile it and run it? And it can I can show the logs over here. So what's it's doing over here. As you can see, it received the message and it's doing all this work. And let's see if it can. It takes a bit of time because it parses this information and compile it and then run it. So let's see if it can. I'll wait for a second. If it cannot, then I'll move on. Okay, so there is some issue over here, but trust me, it works. I in fact tried a few minutes ago. So moving on. So that's one part, and so there is some exception over here that happens, but I'm going to show you a different one, which involves tools and Sharp mentioned about RAG, which is retrieval augmented generations. That also I'm going to show you quickly. So to do that, I need to run a separate project, which is this. So running would take a bit of time. So while it's running, I'm going to show you the UI. So the UI looks like this. As you can see, it's a shop. It's a bookstore, right? It has lots of books, and when I'm a user, sometimes I need to find a book, but I probably don't know the name of the book, or probably don't know the author of the book. So how do I find that? And what I can do is over here, I can chat through this. So it's still running. It will take a second, I think. So let's see it. Okay, it's still running. Hopefully it's ready now. Okay, it's ready. All right. So over here, what I can do is I can ask, hey, do you have any books on modern concurrency? Something like that. Hey, do you have any books on modern concurrency? Let's see what it returns. I can obviously full screen and discuss over here. And it's found 2 books. So next step is I want to add this book to my cart, obviously, right? So I can basically tell them in my natural language, hey, can you add this book to cart so that I can buy, right? And as you can see, it added these books, both of them, to the cart. And let's see what it says. Could you please specify which book would you like to, add to your cart? So it's basically asking me questions. I can say I want to add the second one, which is, in a natural languages. So let's see how it does. As you can see, it says I've successfully added modern concurrency in Java. And I can see over here, it's already added in the cart. And as you can see over here, it's 29 in stock. So initially it was 30. Now that I have added in my cart, it removes 1 from the cart. So how do we do all of those things using in LLMs? So that's what I'm going to show you in the code. It's pretty simple. I'm going to skip the web logic, and Jakarta EE part. I'm going to assume that this is something those who are, Jakarta EE developers already knows. But if you don't know, you can just, later read the source code and figure it out. So over here, we have a called bookstore services. And this is a pretty simple Java classes, right? But all the method has a tool annotation over here. So as you can see, it has a tool. It has also a tool, over here. It search books by category. This one is basically searched by title or author. If I provide a title or authors, it will find that books from the database and provide it me. So these are the so the idea with this tool basically is LLM has context. It does a lot of interesting things, but if you want to integrate our local business logic, our specific business logic, we can take this advantage of tools. That's basically abstracted away by the LangChain 4j. So I think I'm pretty much out of time. But also there is a rec part, which is basically we have certain documentations, for example, general information about this store return policy, shipping policy, right? LangChain LLM are not supposed to know this. These are the internal information. But if user asks those information, how do we share them? So this is what actually it does. If I ask over here, what is the return policy? So it will be able to, give those information over here. So how does it work? It basically over here we have a RAG ingester. It's pretty simple. It's load all this information from the file and it ingests and it embeds. For right now, we are using a in-memory embedded store, but we can also use database over here. So that's all the demo I had within this time. But if you want to learn more about this project, we are building it. We have like tons of examples over here. It's an 9-step project. So both feel free to go to this repository and clone it and try it yourself.
Thank you so much. It was a incredible demo, and you put the oomph and the hype back in Jakarta EE, because now people can go and they can modernize it and they can make it like the Gartner hype cycle there right at the top there, along with everyone else. And we've got a lot of other speakers to speak on AI. So my question to you is Jakarta EE your first choice now for an LLM? In your experience, and this is a hard question here, would you go straight into Jakarta EE, or in your experience, were you kind of like, maybe it can't do it as well?
Jakarta EE is really an important technology, and many of the other technology are built on top of the idea of Jakarta EE, all the Jakarta EE specifications. So as a Jakarta EE ambassadors, I personally like to work with Jakarta EE. Yeah, why not?
Well, ironically, we have our next speaker who actually is going to speak on AI also. And then maybe if Dan, if you were there, you can just give us a nice segue from your talk. I want to thank you. And I'm not trying to butcher your name, Balzer and Shaf, for the incredible talk there. And Dan, yeah, so you're leading on from the first talk here, and we're going to bring you on here, and you're going to be speaking on AI for Java developers, which I'm a Java developer. I like AI, and actually, I think I've got a few certifications in Jakarta EE. I love those books that you had there also, though. So I want to introduce Dan, and let's say goodbye to Shaf and Balzer. Thank you so much. Dan,
hi, how's it going? Yeah, I want to get that book from Balzer on modern concurrency. That looks like a really good book, so I'll have to pick that one up.
I actually own that book. It's in my cupboard.
I gotta get it.
Yeah, so you're going to be speaking on AI for Java developers. Hot topic, really hot topic. Everyone needs to talk about it. But if you had, say, agents for AI developers, even hotter. And if you went MCP for Java developers, even hotter than that. So I'm very keen to see.
I love talking about all those things. My colleague Adib talked about building agents in Spring AI earlier. I'm going to talk about AI for Java developers. I'll mix in some Spring because I am a Spring developer advocate, but a lot of the things we talk about are high level just for any Java developer. So I'm excited.
Okay, so I'm going to hand it over to you, and then I'll meet you at the end to segue into the next speaker.
All right,
over
sounds
to you,
good.
Jen.
Thanks a lot, Rory. Appreciate it. All right, looks like my screen is up. So I'm going to go ahead and get started. Again, this is AI for Java developers. We're going to use Spring AI, but I'm going to kind of talk about some concepts at a high level. So I hope this will be helpful to everyone. A little bit about me. I'm a Spring developer advocate for Broadcom. You can learn more about me at danvega.dev. I am a Java champion, a soon-to-be author. I just have a few slides here, and then we'll get into some code. No, we don't have a lot of time here. So if you're on the O'Reilly platform, I have a book coming out with my friend Nate Shuda on the fundamentals of software engineering. You can check it out. But the topic at hand is Java and AI. And I want to start here because a lot of the discussions around AI happening have been with the Python space. And rightfully so. There's a lot of really great frameworks, a lot of really great projects in the Python space for everything, right? But for a lot of the things that we've been doing over the last couple of years has been building up these large language models and using machine learning and data science. But now we're at the point where all of the languages out there are now consumers of these large language models. And because of that, you know, any language can talk to these large language models. They'll have REST APIs. You can talk to it through an endpoint. So Java is uniquely positioned because when it comes to Java, there's a great opportunity here. And Java powers 90% of Fortune 500 companies' backend systems. So when you go into the enterprise, Java is everywhere. And now AI capabilities are now expected in enterprise applications. So Java is uniquely positioned to be front and center with these AI generated or AI capabilities. Java developers have a unique market advantage with these AI skills. You've probably heard, you know, over the last year or two, some of the different use cases. We'll talk about these. Being able to kind of process documents, go over documents, your internal documents, get extract knowledge out of them. The general chatbot that we've seen, right? Like being able to provide intelligent customer service automation. One thing that I've really enjoyed lately is obviously the code generation out there, the IDEs that are doing all these really cool things, but really being able to like build these kind of developer productivity tools. So I find myself building a lot more tools for myself to kind of solve my own problems. So that's been a lot of fun. And then in the enterprise, kind of predictive analytics with your enterprise data. I want to start here with Java, right? Before we even get into Java, really. If you go sign up for something like OpenAI to get an API key, to use one of their foundation models like GPT-4o, you can actually write an application that just curls the endpoint. So here we have an API key. We curl the endpoint /chat/completions. We pass in a prompt, and what we get back is a response. There's some metadata around this. So like, what model are you using? Here's the response, that little content string there. And then there's usage like tokens, prompt tokens, completion tokens, total tokens. What are those? We heard about some of those in the last talk. I'll kind of talk about those again here. But this is kind of the response that you get back from an API. And we can do this in Java too, right? So we can go ahead and use JDK11's HTTP client. Similarly, we just create a post to that completions endpoint, and we get a response back. And so if we can do this, whether it's within a bash script or within Java, then why do we need anything else? And the reason for this is as we start to build these real world applications, we're going to run into some unique problems that we need to solve for. And you can solve for them on your own, or you can let a framework kind of do some of the heavy lifting for you so you can focus in on the task at hand. So things like LangChain4j, things like Spring AI, they are much more than a facility for making a REST call to an endpoint. If that's all you needed to do, we wouldn't need something like this, right? And again, I'm going to show you Spring AI. We've heard from a lot of folks on LangChain4j. I just want to make it abundantly clear that like we are past the building up these large language models. We are now consumers of them. So however you're consuming them, great. Spring AI is one avenue to do that. So I'll just quickly tell you about Spring AI, one slide, and then we'll dive into some code. So Spring AI, for me, I have AI for Spring developers, but really it's AI for Java developers. The same way that I got into Spring in the first place was Spring allowed me to like build these enterprise applications, right? It gave me a framework. It gave me the infrastructure for building these, so I can kind of focus in on the task at hand. And I like to think of Spring AI as that too. It's that infrastructure for building generative AI applications for Java developers. You can learn more about this over on spring.io. This was started by the great Dr. Mark Pollock. The current version is 1.0.0 milestone 6. But if everything goes well, milestone 7 is coming out tomorrow, and we are getting closer and closer to that 1.0 release, which is really exciting. One of the things I really love about this framework is you get a portable API support across AI providers. You probably noticed there's tons of different providers out there, whether it's OpenAI or Anthropic or Google or Microsoft, right? We have like all of these different providers out there, all these different models. And we don't want to write code to specific models because models are changing all the time. And next week, the best model that is going to win all the benchmarks is probably going to come out, right? So we have this ability to write code to an interface. There's a check client. We'll see an example of it. But that allows us to write a portable API. So we don't have to write specific code to specific LLM. So if you need to switch out a large language model, you can just switch it out and use that. So that's really nice. We'll see an example of this, but there's times when you may want to make a blocking call where you just need a simple response. But there are times when you want a streaming response, like when you're on a chatbot, right? When you're on ChatGPT, you don't want to wait for that entire response to come back. You get that immediate feedback as it starts streaming that back to you. And this was inspired largely by some Python projects like LangChain or Llama Index. So that's all I got for slides. I want to take a look at some code. Before I do, I want to talk about a couple concepts that we heard in the last talk, and that I just kind of, I think, kind of reiterate in what these things mean, because they become very important. So one of which is the context window. So we hear this word, the context window. This refers to the amount of text or tokens that a model can see and consider at one time when generating a response. So we have this context window. There are these different types of messages that you can send. And I'll come back to this, but I want to go over to something like ChatGPT and say, let's ask it a question. How many episodes of Daredevil Born Again are there? So as we type this out, that message that I just sent was the user message. So there's a user message. What came back from the LLM is the assistant message or the response. So these are starting to fill up the context window, but how are they doing that? I'm going to copy that user message that I had. There's a bunch of tools out there that can do this, but these tokenizers let you kind of get a window into what a token is. And so if we go ahead and paste some text in here, if we look down here, the token roughly translates to 3/4 of a word. So 100 tokens is roughly 75 words. And as we paste this text in here, we can see how the large language model broke this down into different tokens. So this is a good way to kind of visualize that. But our message was part of that context window, but so was the response that the system sent back to us. So if we go ahead and put this in here, we now see that we're at 117 tokens. And as we're chatting back and forth, we start to fill up the context window. And this becomes important for a couple of reasons. So I'm going to come back over here, and we saw the user message and the assistant message. There's a system message that can be like the overall context of what we're trying to do in that chat. There's tools, as we saw in the last talk, that can provide extra functionality. All of these things fill up the context window. And when it comes to that, these tokens are the currency of an LLM. This is how we are paying for this service. So just understand that we're starting to use, we're putting messages in, these things translate into tokens, these things cost money. And this is important because every large language model has a different context window size and has a different pricing structure. So if we look at something like GPT-4 or 5, we have 128,000 token context window. That is the most you can kind of put into one conversation before it starts losing reference to things that we are talking about. But more importantly, the pricing is $75 for 1 million tokens in, which we send to the LM, and $150 for 1 million tokens in the response sent back to us. That is very expensive compared to something like Gemini 2.0 Flash, which is 10 cents for 1 million tokens in and 40 cents for 1 million tokens out. So these, understanding what the context window is, understanding what tokens are, and then understanding that this kind of all fits into the pricing is pretty important. So I'm going to go through a couple examples today. This is the repo that you can check out, github.com/Dan Vega, Spring AI Workshop. We are not going to get through all of these because we have, we're down to 15 minutes here, but we'll go through a few. And if you want to use this as a reference later, it's a good place to kind of look. So the way I would get started is I would come in and fill in some metadata over at start.spring.io. I can fill in what my project is, and I can pick some dependencies. The nice thing here is, and I'm actually going to remove this one, I'm going to build a web project, and now it's time to figure out which large language model I want to go ahead and select. And as I said before, this isn't the critical selection that you need to make, because we can always switch out the large language model later. But if you go in here, you can see that we have support for all of the large language models out there. In fact, if you go over to the documentation, the Spring AI reference docs are really good. It kind of lays this out for you. But I want to say I want to use OpenAI, and that's all I need. So I can go ahead and generate this project, open it up in IntelliJ, and I'm ready to go. So I want to start off just by showing you how easy it is to get going. We have defined the large language model as OpenAI. So I just need to fill in a couple of properties here. I need to define my API key, because we are not using like ChatGPT. We are using AI, the API. So we need to have an API key for that. And I went ahead and created an environment variable for this, so I don't leak my credentials there. And then I'll go ahead and define the model. So every large language model, there's different versions of the model. We saw GPT-4o, 4.5, 01, 01 mini. They all have like different pricing structures. So you want to be very specific with which one you're using. In this case, I'll use GPT-4o. There are more things that you can configure, but this is all you need to do to get up and running. So with that, I'm going to go ahead and create a new chat controller. So I'll do this. This is a REST controller, and we're going to get an instance of the chat client. So chat client. And this is going to get configured for us. So we'll use this builder pattern. Builder.build, and we can configure some other things on this, but I'm not going to now. But again, this is the interface. So there is an interface. There's a chat client here. There's a default chat client that gets created for us, and this will get auto-wired in for us. So again, if we were to go in, change the large language model to something like Anthropic's Sonnet 3.7, this code is not going to change, just the configuration underneath the hood is. So I'm going to create a simple get mapping here to /chat, and this is going to return a string. And all we're going to do to get started is use that chat client. So I could say chat client.prompt. I can give it a prompt like, tell me an interesting fact about Microsoft. And we can go ahead and use the blocking call. So in this case, I'm expecting a simple response. So I don't mind that it's blocking. We'll see an example of a streaming response in a second. And then there are different response type I could get back. If I wanted to get a lot of that metadata that we saw earlier, like how many tokens are being used and some other things on the response, I can call chat response. But in this case, I just want the string response. So I'm just going to return the content. And that's all there is to it. I'm ready to go. I'm going to run this application. Hopefully, if nothing is running on 8080, we should be up and running. And we are. So I can go over to a terminal, and I can just send a GET request to localhost 8080/chat. And we will see a response here. So an interesting fact about Microsoft is that it was founded in April 4th, 1975 by Bill Gates and Paul Allen. I'm not going to read the whole thing, but you get the idea there. So that's it. That's how easy it is to get up and running with Spring AI and talking to a large language model. Now, I mentioned that this is a blocking call. What if I wanted to have a better user experience? So when I go to ChatGPT and I type in a prompt, I immediately start getting some feedback, like some response coming back to me. And if I have larger responses, that would probably be a good idea. So I'm going to call this stream. I'm going to create another method here. I'm going to do something similar to this, but instead of calling call, I'm going to call stream. Yes, this is going to break, but that's okay. And I'm going to say I'm visiting Atlanta, Georgia. Sorry. Give me 10 places I must visit, right? So the only thing that changes here is now we are not just returning a string, we are returning a flux of strings. So I am going to go ahead and rerun this. And again, we're going to come over to the terminal. This time, I am going to use the stream. So we get that streaming response back. And I'm going to call stream. And now you'll see immediately I start getting responses back. So we have support for both blocking calls and non-blocking calls where we can start to stream the responses back. Again, this is pretty important when it comes to user experience and you're doing something like a chatbot, right? So those are my two examples that we get to live code together. Again, because we're short on time, I'm going to show you some code from that repo that I showed you earlier, but you can go ahead and go through this on your own. The other thing I want to talk about that I think is pretty important is something called structured output. And I'm going to go back to the browser for this. So here I am over on Google's AI Studio, and I want to go ahead and ask it a question. Please name all the teams in the NBA, right? So I'm a big basketball fan. Tell me all the teams in the NBA. Oops. And if we do that, it's going to, oh, I think I have, yeah, I have like a, I don't need all that on there, but I have no idea what that response was going to be. It could have just like put them in a string. It could have done what it did here and list them out by conference and division. If I'm just kind of chatting with a large language model, I don't really care what the output is. But when I'm working in an application, output really matters to me. And so because I want to take that output and probably turn that into some type in my application, right? So all these large language models have a way, well, not all of them, but a lot of them have ways to structure the output. So here in AI Studio, it gives you the ability to come in here and say, okay, how do you want this structure outputted? So I could say I want a property called teams that is going to be an object, and this is going to be an array of object. And I could say team name is a string, and city that they play in is a string. So now if I save this and ask the same exact question, instead of getting some random response, I am getting a structured output here. I'm getting an array of teams with the city and the team name in them. So now if I know that that's coming back, I can work with that type in my system. So again, as I said before, each of the large language models kind of handles structured output differently. But Spring AI actually handles all of this underneath the hood for us. So I want to see an example of this. So I have this Git mapping. And if I were to call it unstructured here, I said, what's a good vacation plan while I'm in Montreal, Canada for 4 days? Again, we really don't know what it's going to send back to us. It can just send back a whole bunch of gibberish. I could send back in whatever response format it wants. But in this case, I'm saying the same thing, but instead of saying just give me that string content back, I'm saying turn that into an entity. And that type is itinerary. And an itinerary has a list of activities. An activity is made up of an activity, location, day, and time. So I'm being very specific with what I want back. Underneath the hood, Spring AI will take that kind of JSON schema, send that along in the request in the user message, and say, this is what I want it turned into when you come back with it. So if we go ahead and run this again, oops, we are over here running that one. Let's run this one. And then what I can do now is go ahead and, what was this? Vacation structured. So if I say 8080 vacation structured, instead of just getting some random things back, we're actually going to get this itinerary, which has a list of activities. We'll just wait a second. Again, it is a lot of content. So itinerary. And we have activities. So an activity, the day, location, and time. So when we are working in, this is one of the problems I was talking about before. Like, yes, you could just call a REST endpoint, but then you'd have to like figure out how structured output works in that particular large language model. Then you'd have to use something to kind of deserialize that into a type. We're kind of handling that for you underneath the hood. So all you do is pass it a type. Now you have a type that you can work with in your application. So structured output is one of those things that you have to deal with. Another is, we've been talking a lot about text, but a lot of these large language models support different modalities. So it can support images, audio, video, etc. So I have an example here, and I have this image. And if I look at this image, it's a little nook with a laptop, coffee, glasses, etc. And what I'm going to do is I'm going to do the same thing I did before. I have this chat client. When I pass a user message, I'm going to give it the text, hey, can you please explain what you see in the following image? And I'm going to pass the image along in this request. So now if we call image to text, I'm going to say 8080 image to text. And it's going to be able to look at that image and then answer the question that I asked, which was explain what you see. Says the image shows a cozy bed. There's a laptop with a visible logo on the back. In the front of the laptop, the eyeglasses, etc. I'm not going to read the whole thing, but it gets very descriptive of it. So we're not just talking about working with text. We can work with different modalities if the large language supports it. So another thing I want to talk about is stateful controllers. So when we work with something like ChatGPT, that is the product that is sitting on top of and talking to the different large language models. The large language models are don't hold any state, right? It is the ChatGPT experience that you have that is able to hold that state. So in Spring AI, we have these different advisors, one of which is for managing memory. And we have a couple of different implementations of this. One is an in-memory chat memory. When M7 comes out, there is a new JDBC chat memory. So you can start to persist these conversations to a database. But again, what this does allow you to do is I can make a call to, so something like memory, and I can say, my name is Dan. And then if I say, what is my name? It knows my name is Dan. How can I help you today? But again, if you don't have that functionality built in, that's that's another thing that you're going to have to kind of solve for. So those are some of the main things. I'll show you one more, and then we'll kind of wrap this up. Again, some of these, some of the problems with large language models, some of the limitations, I will say, not problems, is that they don't have access to real-time data. So we have different solutions for this, right? We can add information to the context. We can use something like RAG. We can also use something like MCP. There's also something called tools. So a tool is just giving the LLM some extra abilities. And in this case, I'm going to describe a tool that allows you to get the current date in the user's time zone. And so when we go ahead and call this and ask this, we can say, here's a tool that you have available. And so when it's asked the question, it goes, oh, I don't know the answer to that. but I do have a tool that can answer that question. So it will go ahead and call that tool. You get the response. You send that as part of a context back to the LM, and now it knows how to answer that. So again, there's a lot of information in this repo. If you want to look through it, there's a lot of different examples on how to use Spring AI and solve some of the problems that will come up as you start to build out generative AI applications. So that's all I got. If you want to find out more, you can learn more about me there, and always feel free to ping me. I love answering questions. I love talking about this stuff. So yeah, reach out.
Really smooth, Dan. And the next speaker we have is Jonathan, who's going to be speaking on AI in large-scale automated refactoring. Now, I would love to actually take all of these models and actually go and benchmark them. I'm a big benchmark fan. If you go into Hugging Face, you can see all these benchmarks. Even Azure has, you go into Foundry, it's got a benchmark though. So I'm not saying that we're going to fight Spring against it though, but maybe Jonathan, you allude to it on how we're going to do refactoring and large-scale automated with repos in that though. Dan, thank you so much. Excellent talk. And Jonathan, I want to bring you in here, and I want to introduce you here. You are co-founder Moderna. Oh, okay, great. One of our partners. Great to meet you. And yeah, tell me a little bit about what you're going to be speaking on.
Yeah, so what Dan was doing was talking about coding with AI, and I think I'm going to transition to a slightly different application, which is using this in the service of rewriting large portions of your existing, let's say, legacy or existing code in the organization. So something that doesn't get talked about a lot. Interesting subject.
Okay, I'm going to hand it over to you, and then I'll come back there and we'll do the segue. Over to you, Jonathan.
Thanks, Rory. Yeah, so we're going to do a quick study in how to build up, ultimately at the end, kind of an agentic workflow to do large-scale transformation deterministically across the whole organization. But before we start, I mean, I think it's worth at least taking a survey of where we're at. And as we all know and have probably experienced at this point, AI for code authorship started with completions, and really GitHub Copilot was my first experience with this, and still the Copilot or code assistant I use to this day. This is something that provides that magic, sweet ghost text in the IDE that really complemented the IDE's existing capabilities by kind of filling in all the gaps where the IDE was doing things deterministically but didn't really know how to do the more these are sort of esoteric cases. So you see in this example the model's filling in this description text for me on because 42 was the answer to life, the universe, and everything. So super creative and fun. That's sort of grown into this next crop of tools that do authorship or net new code development in more or less an agentic manner. And again, GitHub Copilot chat was one of the first on the scene here, where it's really bringing the chat interface forward, and the IDE or the actual editing in the editor kind of recedes a little bit to the background, at least proportionally here. We're starting to see this crop up in many different forms. So, ChatGPT Desktop now has Work With Me, where you really can be chatting in ChatGPT Desktop, which is controlling your IDE in the background. We've seen things like Cursor and Windsurf and so forth. The main goal there really making the chat interface the primary mode of operation, and making the IDE at least the second step to your net new authorship experience. And I think what's interesting is both of these, the completions in the IDE and the agentic experiences now that are helping us with net new authorship, really work in large part because the language model gets information in one way or another from the IDE. In other words, the IDE's knowledge of the structure and types in the code, not just the text of it specifically. The LLM ultimately needs information from the IDE's internal representation because the text there's just not enough information in the text often for it to do what it needs. And so I've provided a really simple example of this here. This is just a Java class, just one simple, 5-line Java class called dog that extends animal. And you see in the speak method, there's a logging statement, a logger.info. That logger is being inherited from the base class animal. So it's a protected or public visibility field that's being inherited. And if you just sit here and look at this code for a moment, the thing you'll notice is that nowhere in these brief 5 lines of code is the type of that logger actually defined. We don't see the definition of that variable because it's coming from the base class. We don't see an import representing that type. So if I were to ask you right now to tell me definitively, is this logger an SLF4j logger, or is it a log4j logger, or which is it? Because they all have very similar method signatures, you couldn't tell me. I don't know, as experienced of a developer that I am. And no matter how many billion parameters we throw into a model, a model looking at the same text has no better idea than I do. And so the compiler ultimately needs to figure this out as part of its work in producing the bytecode at the end of the day. And the compiler does that by taking the text. If you go back to your compiler's class way back when in schooling, it turns that text into what we call an abstract syntax tree. So it breaks down this text into a class and its method and a block and a method invocation inside of that. But the second step after the abstract syntax tree is the compiler goes back through and does all this symbol solving, and it does that deterministically and algorithmically. So it's looking at logger and it says, what is that type? What is the declaring type of the info method? What are its argument types? And it adds that information to the abstract syntax tree. If we take the combination then of the green things, the syntax, and all those symbols of those types, and then also throw the formatting, all the white space, and a bunch of other metadata onto that tree, that together is what I call a lossless semantic tree, or an LST. And keep that in your mind for a moment. We'll come back to the lossless semantic tree in a moment, but just know that this kind of representation is what's kind of going on in the IDE, and that information in one way or another is being supplied to these models to help them make informed decisions. So as amazing as all these experiences have been, and again, I'm using Copilot every day, I'm using ChatGPT Desktop, I'm using other tools, and it's really accelerated my development. It really does focus on net new code development. And so there's this sort of elephant in the room, which is all the existing code that I have, and that could be hundreds of millions of lines or thousands of repositories of code. We've even seen at some organizations upwards of 4 or 5 billion lines of code, either new or old, under management. And so how do we take those same kind of amazing experiences we're seeing with the net new code development and apply it in service of upgrading and modernizing and securing that old code base? And I think, so if we think about why models are very good about authorship, it's because of that information. So what do we have to do to accomplish providing that same information? We know that we can't just open whole business units at once in the IDE, right? This would be we know as developers, whenever you open in a large repository in the IDE, it goes through this long period of updating indexes, waiting for scanning to complete, resolving dependencies. And this, even to this day, because of course our repositories have continued to get bigger and have more and more dependencies, that could take minutes. It could take a long time. It's kind of one of the things we dread, is having to invalidate caches, because you're in for a potentially long wait at the end of the day. And while it's always seemed kind of a background thing to us as everyday developers, what's really happening in the IDE when it's doing that, when it's updating indexes, when it's resolving dependencies, is it's working its way towards building kind of a representation like this, and caching it, and that's what it's going to use to provide really advanced completion hinting and things like that to you throughout your day. So, can you imagine having to do that for 4 billion lines of code? It just really wouldn't be sustainable. So I think the goal then would be to expose a similar richness of data that the IDE does somehow to these models. And that's where I have to go back to a technology that, not thinking about this problem the way I do now. I started back at Netflix about 10 years ago as a member of the engineering tools team. It's called Open Rewrite, and Open Rewrite is really a large-scale refactoring solution. Our goals back at Netflix were to help product teams upgrade from Java 6 to 7 and 7 to 8 at the time, to move from one logging framework to another, to fix vulnerabilities in their code. In general, a concept I now call tech stack liquidity, going from one place to another in the code. That could be a migration, it could be moving from one product to another. Anytime you have to go through your code and kind of laboriously change it the same way over and over and over and over again. So Open Rewrite, as an Apache licensed refactoring technology, consists first of a series of parsers. So for Java and JSON and Kotlin and HCL and now JavaScript and Python and C#, etc., protobufs, etc., that take the text to code and some more information about their build configuration and turn them into that lossless semantic tree. And then we have what's called recipes, which are deterministic programs that are designed to make changes to that tree that can then get materialized back out to source code to affect some change. So that was I said a lot there, and I think if you haven't experienced this, it's easiest just to see a few examples of the kinds of transformations that Open Rewrite recipes produce on code. For that, I'm going to show a number of examples here, and I'll start with one that's constrained. It's infrastructure as code. It's Terraform. What you're seeing here is really, app.modern.io, which is just about 4 billion lines of open source code that we're parsing into that lossless semantic tree. And Modern's basically taking those Open Rewrite recipes and scaling them to run them on hundreds or thousands or sometimes tens of thousands of repositories at once. I had ran this recipe, which is a collection of recipes for best practices for Azure, and we found an old 7-year-old Terraform example that at this point has sort of default insecure, defaults that you wouldn't prefer anymore. Like, the default is still TLS 1.1, so you would want to change that to 1.2 or greater. It's, still has HTTP traffic on, so you want to kind of disable that and so forth. And so the recipe is producing the change and kind of materializing it back out in a way where I could take this then and commit all of these to source control or create a PR or something like that. A few things about these recipes as they run and produce changes on code, they are really programmed. So we haven't gotten to the AI part yet. The changes that you're seeing here are going to be the same every single time you run this recipe. Also, recipes are designed to make changes that look idiomatically consistent in the context of the repo they're being inserted into. Notice here that the recipe kind of detected that this Terraform uses this aligned key value type syntax, and it's inserting new properties that are actually longer than the original one, so it knows that it kind of has to bump all the equals or assignment operators over a little bit so that they align still in the style that the original one did. And the goal of that with the recipe is to make the change look comfortable and homey to the developer. They want to recognize it as code that looks like the code around it. That helps for them to, obviously it's just kind, and it helps them to accept change more quickly. So this was one kind of change. A larger one is really something like Java 8 to 11 to 17 to 21. And this is going to have a lot more changes, both in dependencies and configuration and in code itself. And so I could ask, for example here, why did this change? And you can kind of see here how recipes try to provide developers with both a narrow context, like I'm using Java 17 instance of pattern matching because I'm trying to move to Java 17, because I'm trying to move to Java 21. So this is an explanation of why I'm asking you to do this kind of thing. And in this case, this was ran on just a series of a couple hundred repositories, changed 4,000 files. This is work I don't want to do by hand, to get that work done. Just another example. So recipes, in addition to making changes, can also just put little search markers on the lossless semantic tree, and those get rendered in different ways as like highlighted text in the diff output that we produce from different mechanisms that run open rewrite recipes. That ability to search allows us to find usages of APIs and dependencies and so forth. Here's an interesting recipe we ran called find usages of deprecated methods. And we ran this recipe to look for just deprecated usages of the Spring framework and ran it on the 156 repositories that the Spring team itself owns. And it's kind of funny in a way that you can see where it's hard for them to even keep up with their own deprecations. The get scheduler properties was deprecated at the time this was compiled. If a developer opened this file in the IDE today, they would see that little yellow squiggly line right under that line suggesting that this was deprecated. But that's the thing with code that we have on the shelf. You can't have every file open every day, or we would have noticed this and we would have addressed it. So this recipe is really designed to just go ferret out those places where you still have those places which are subject to deprecation. So that's a search recipe. Another example of that is a recipe that just looks for direct and transitive dependency usages. So I was looking in this case for all the usages of Jackson. I said com faster XML Jackson star, etc. And it located that this Spring Boot starter web Maven dependency transitively or indirectly drags in Jackson data bind 213 2.1. So, and then, it's of course going to do that for Maven and Gradle and many different kinds of versions and build those things up. These are just, a few examples of recipes. I think the key to understand here is that there's many different types of them and combinations of them. What changed in the AI space late last year was this new paradigm called tool function calling, which allows models to be supplied with tools to do work, and then the model decides, based on the tool's description and the work that it has to do, when and where to call that tool to perform the work that it's assigned to do. And so this has been something I've been developing for 10 years. We've been developing thousands and thousands of these recipes, and it's just like a light bulb went on, and suddenly all of these open rewrite recipes that we had that could dig deep down into text, below the text of code, to see all these different kinds of things like this, became ideal tools that we could supply to a model to help them do work. So I'll show you how that winds up looking when we expose all of these recipes, these open rewrite recipes, via MCP or Model Context Protocol to a model to allow it to do some sort of, in this case, we're going to do a code search. So if I back up here a little bit and start this. I've got, at this point, Claude Desktop opened, although there's quite a few AI-based tools now that support the MCP protocol. This was one of the first ones, of course. I'm essentially attaching a series of tools and prompts to that chat client. And so the actual tools I'm providing are one that's just called search for recipe. In other words, dig through the thousands of recipes and look for something that's close to what you want to do. Another one is called run with options, run a recipe, process the output of that recipe, describe its options, and so forth. And so let's say I've selected some business unit, and I'm talking potentially tens or hundreds or thousands of repositories worth of lossless semantic trees that we've produced and stored on disk. And I ask a question like, how is Guava used? What does that really mean? I'm going to leave it up to the model to figure that out. It says, I'm going to help you find how Guava is used. And, Claude Desktop is asking me whether it's allowed to use each tool. A big concern, of course, with the MCP standard is the security of this, but so it's going to ask me for the first time it uses each of these tools. But it's first of all just looking for recipes that it thinks could answer this question. Curiously, the first one it selects is called No Guava. It's a recipe actually to migrate off of Guava. The model decides to dig deeper and really try to understand the options available to that recipe. Doesn't like what it sees. It really isn't the right thing to use. Looks for another recipe by refining its own search. And this was all done sort of autonomously. Interestingly, it finds this recipe called find methods. And so it's reading the description text on that recipe itself, learning how to use the options that are available to it. And it's essentially at this point changed my question about finding Guava method usages, Google Guava method usages, into the package pattern, com.google.common, any subpackage star, any method name, any number of parameters. So really is just from the recipe description text, learned how to use this recipe and selected the appropriate data table, which is just kind of the thing that comes out of the recipe, the column or data that comes out of the recipe. And then it starts running it. And after a short while, it's ran that recipe on the whole business unit and says, these are the 4 key ways in which Guava is used. What I think is interesting is that once a model has that sort of structured information provided back to it, you can start going more multimodal on this. So I could say, could you build a histogram of the most common usage patterns that you've seen here? And it's going back and looking at all of those usages that the recipe reported and trying to summarize and understand what the prevalent pattern was. Now, while this is running, I think it's interesting to note that the recipe itself, because it's deterministic, because it's operating with everything that the compiler knows about the code, will not have any false positive matches on Guava, nor will it miss any occurrence of Guava, because that step, at least the production of the data, was done in a really deterministic way ultimately. The model's deciding right now to take what it's kind of now learned, and it's writing out a quick React component here to present it in that histogram form that I originally asked for. And here you see the result of that. It's just, this is quick, large-scale impact analysis in a way that I have not seen before. The ability to kind of marry up a chat interface, which is fuzzy and probabilistic in nature, to a deterministic system to make this kind of change, very usable to somebody. These recipes, while there's thousands of them, I kind of go back to show just how deep they can get in combinatorial ways. Just looking at a visualization of the recipe that helps folks move from one Spring version to another. We have this recipe called Migrate to Spring Boot 3.4, and each of the dots here in this visualization represent a sub-recipe of the larger task of moving an application to Spring Boot 3.4. No wonder we're not keeping up with this stuff, right? We're asking people to understand, 3,300 different types of changes that they may have to do to their code base. So these recipes are stacked in really composite ways. To migrate to 3.4, you first have to get to 3.3, which means you have to get to 3.2 and 3.1 and 3.0, which in turn means you might have to migrate to Java 17, which means you have to get to 11, which means you have to get to 8, which means you have to get to 7. So you'll see how these kind of just stack up on us. And each one of these steps, this kind of subtree over here, represents an open rewrite recipe you could run in isolation to just do this migrate to Java 17, and then you go back to maybe on a second step to running the larger recipe. So people break down this into multiple steps to make it easier for them to review in many different ways. The thing that has me, I think, really, really excited, the question is often, okay, how did all of these 3,000 recipes come to be? They were contributed by, there was a contributor from JP Morgan that wrote quite a few of these. There was some contribution from the Spring team. We wrote some of them. The many hands made this recipe that can help many other, developers migrate this. But how do we make the act of net new recipe development itself faster? And I think what I'm really excited to see just in the last couple weeks now is that the agentic code authorship experiences, the ones that are helping write net new code, are able now to write complex code migrations. So it's, in other words, we're using a model for what it's good for, which is writing net new code. Only the net new code that it's writing is the recipe, the open rewrite recipe, that will then deterministically change thousands of other repositories to do something. We did a commit just a couple days ago where one of the AI code assistants wrote out in large degree the Hibernate 7 migration based on a Hibernate doc, and you see how complex some of these recipes get. Migrating the Hibernate session, and some of them are easier because it's just dependency updates that the model can configure declaratively. But I think what I guess just kind of at the end here, I think we've found now this real symbiosis between what AI is good at, net new code writing, to do what it wouldn't be good at, which is kind of large scale predictable change across whole business units. And this is just the real exciting development to me in 2025.
Yeah, if you have a visualization like that, Jonathan, you can't go wrong.
That's right.
You can't go wrong. If you show it like a universal thing that you can rotate and everything like that. And I stopped what I was doing. I was going, oh, pictures, pretty stuff.
This visualization itself is something. I went through many iterations of something like this to arrive at this particular one, but it helps folks know just how deep these get. It makes you sympathize.
I put in some music and I vibe code it there, and Cloud Connor 3.7 will create it. I think that if I could do that, hey, I would just hit Nirvana there. It will be absolutely excellent. Wonderful talk. I use Open Rewrite. We use Open Rewrite. We've actually got a speaker coming on a little bit later that is going to showcase how we use Open Rewrite with that. Great. So it's called our Java upgrade wizard, which is just ironic now. It's not competition, okay? We're all in it to win.
I love the partnership. That's what we think should happen, is really that everybody needs to pitch in a little bit to write the recipes to cover the whole ecosystem and really benefit us all. So I love the collaboration we see across up and down the stack.
But they won't have a visualization. Okay, so you won already.
There you go.
Okay, so and I've got the next speaker who actually, I want to segue into them, Joshua. I want to bring him on here. I actually work with Joshua. So he won't have a visualization, but he is part of my team. So, he is automatically got the points and everything. Jonathan, incredible talk. I want to thank you so much for coming and spending time with us today. And Yosha, you're going to be speaking on modernized Java apps with your favorite tools. Now, I'm very opinionated about my tools. Every developer is, okay? As long as you don't mention Vim or Emacs, then it doesn't get violent. But yeah, and I'm very keen to see what you're doing, and maybe I could learn a little bit from you, and then be a little bit of competition because we are in our own team there. So I'm going to hand it over to you, Jonathan, and then I'm sorry, Joshua, and then I'll meet you at the end of your talk.
Yeah. Thank you. So hello everyone. So I'm Tirana from Microsoft. Thank you so much for joining my session. So today I'd like to talk about the practical aspect of the modernizing Java application. So could you wait a moment, please? Yeah. Today I'd like to talk about my session. So can you see my screen? Okay. So specifically focus on the migrating them to the cloud using the various tools and the techniques. So when it comes to the application migration, so it's essential to consider the different method and the strategy based on your system current situation. So today, I will cover this kind of the topic. And at first, so please consider the Modernize with 7 R's. So you need to think about how to apply the Modernize your application. So generally, it is very important to consider with the 7 R of modernization as shown here. So for example, so you can rehost, replatform, refactor as needed, and also so you need to re-architect, rebuild, and then replace. And also ultimately, so for outdated system, so you may need to consider the retiring the system. So while there's a various approach based on these 7 R's, however, so I don't have enough time to cover all of them today. So therefore, we will focus on the two specific areas, so refactoring and the re-architecting as shown here. So this will be the main topic of today's session. So at first, I would like to inform you one thing. So unfortunately, there is no such thing as a magical tool that can do everything. However, so if you combine the various tools, so you can reduce the time reduction will be available, is possible. So please try to use various tools, not only one tool and not only one magic tool. So and also the evolution of the AI is incredibly rapid, and what was common knowledge just 1 year ago is now unavailable. To elaborate further, the situation has changed a bit since I submitted the goal paper. So as a result, the contents I initially considered had also changed. So because the evolution is very, very fast and the introduction of the AI agent has significantly changed the development process in the future, so there will be the noticeable difference in productivity between the developer. So who can utilize these tools and those who can't. So However, I still want to emphasize something important. So AI generate answer based on the probability and doesn't always provide the correct answer. Therefore, so having a solid foundation of the knowledge and the skill is essential. And understanding how to use the AI effectively is highly demanded now. So at first, so I will inform for the beginners for Modernize. So if you don't have the enough experience or knowledge for the migration, so you might feel lost. So in the past, you might have simply giving up or reach out to the very expensive consultant. But now it's the age of the generative AI. So you have the strong supporter is ready to help whenever you need it. So where and how to start for the beginners. So GitHub Copilot will help you the first. So it can answer a wide range of the question related to the development. So GitHub Copilot has three kind of the technology. So ask and the edit and the agent. So at first, so please try to use the ask mode. So for example, so if you are unsure where to start with the migration or the want to check the important point and the consideration, you can write a prompt like this to get the appropriate answer. With GitHub Copilot, you can select many AI model, so like this, so Claude and Gemini and GPT and the GPT-4 O1 model is available. So you can ask the same question to each model and compare the answer and select the one that suits you best. This is just for only the beginner. So even so, experienced the developer might find valuable insight. So please try it. So I want to try to execute it here, but instead I will briefly summarize the key point to watch at when upgraded in Java. So perhaps, as you know, so since Java SE 6 or 8 to Java 24 is so many updated is included. So perhaps it is very, very difficult to understand all of the things. However, at first, for the enterprise application migration, please remember the important thing is remove of the XML related technology from the Java SE. So especially JAX-WS and the JAX-B was removed from the Java SE, and also so for Java EE to the Jakarta EE, so package name had changed from the Java X to the Jakarta. So look like this is a very, very important topic. However, not only this, but also so many change had included. So please, look like this. So prompt and please ask user AI. And so if you understand the briefly overview of the upgrading the Java and the Jakarta EE at the time, so actually, so perhaps you would like to upgrade the system. At the time, so for example, so let's consider the modernizing the application that was created over the 10 years ago. So especially Java SE 6 and the Java EE 6. In order to upgrade this application, to the current version. So at first, you need to understand the current system's status. So so current system analytics is very, very important. So therefore, you first however, understanding the current system is sometimes very, very difficult. So because how is current system be implementing and what need to be done? So and also so for system over the 10 years old, the documentation might be missing, or it might no longer maintained by anyone. So you might not even know if the existing document is accurate, or analyzing the code can be quite challenging due to the large number of the file, and analysis is difficult. So additionally, the developers who originally implement the system may have moved or retired and left from the organization over the past decade, so making it difficult to find someone who fully understands the entire system. But what else can it do? So from the current project, so you can analyze and identify any issue or necessary action. This means so you can also perform the analysis and evaluation. So in this context, so Microsoft has developed a tool called the Azure Migrate application and the code assessment for Java, so known as the APAC. So this tool was based on the open source tool Windup created by the Red Hat. By using this tool, so AppCat, which has been the extending and provide, so you can analyze the source code and the artifact. So which system do you want to migrate, and which cloud environment do you want to move to? So by specifying the target, the tool will inform you the necessary change and the point of caution for the migration destination. So now I'd like to show you the demo for this AppCat. So at first, please access to the Azure Migration application and the code assessment for Java web page, and there is a explanation. So I will start the demonstration from this. So it is needed to use JDK 11 or the 17, and in this time I will use Java EE 6 with the Java SE6 application. And if I execute the AppCat list target technology, it will show the target system and the target cloud system and the target JDK. And this is very, very important. Because in the argument of the AppCat, so we can specify the target, and so we can specify the previous listed results, and from the source code or the artifact of the existing source or the artifact, so we can analyze the system. So it will take a little bit. So sorry. So it will take maybe it will take few minutes. And so after I executed the apt-get command, so on the output directory, so it will create the index.xhtml, and it will show the detail of the application by analyze. And so if there is some issue, then so if you click the link of the issue, so you can list it all of the issue. So for example, so in the past, Java X package was used for the injection. So however, so since Jakarta package has used, and also so currently so the property was included from the file. However, so for the Azure or cloud environment, you shouldn't get the environment variable from the file. And also, so this is very, very important, and I didn't understand actually. So since JDK 11, so class loader, so hierarchy has changed. So look like this information also provided by using this apt-get command. So and also so look like that. So logging property explain that. So the from log get from the file, and also so look like this information was showed. And not only the issue, but also you can understand the project and look like this. So this kind of the HTML and the XML5 is existing on the system, and so in this project, this kind of technology was used, and the EJB and the JPA related information is also provided. So perhaps it will be very, very useful to understand so how to upgrade it, and so maybe you didn't know the knowledge, so perhaps you can get. And after the executed the apt-get command, so by using the AI, so we can also analyze the existing system. So in order to understand the existing system by AI, you can use the GitHub Copilot editing with the agent mode. So perhaps so if you use the GitHub Copilot with the agent mode, so it automatically includes so many files, and so with the agent mode, so look like this instruction and prompt you provide to the GitHub Copilot agent mode, then so you can analyze more detail of the code from the source code. And for the agent mode, currently you can select only 3 models. So depend on your situation, so you can select the appropriate the AI model. So actually, so I tried this you can. I will show the demonstration of the GitHub Copilot with the agent mode. So now, so I'm preparing the Java EE6 with the Java SE project, and so you can select the agent mode, and so in this time I selected the Close 3.7 Sonnet, and I provide the provide prompt look like this. So instruction is so please explain the overview of the project, and based on the analysis, then GitHub Copilot agent will automatically gather the related file and the analysis the project. So analysis point is look like here, and based on this, this is an agent mode, so automatically load the file and analysis the project, and after that, the AI will return the result, and at first it will explain the overview of the project, and after that, it will not only the overview, but also look like the open API, and also diagram of the like a flow chart, and the class diagram, and the sequence analysis, so you can automatically get, and if you copy and paste the markdown file, so you can understand the result. So this is the overview of the project, and based on my prompt, this class system architecture diagram, and the class diagram, and the sequence diagram, so I can automatically get it only few minutes. So in order to understand all of the project from the source code, so you can understand look like this. This is very, very useful to understand all of the project. So maybe if you directly saw the source code, maybe it is very, very difficult to understand all of the overview of the project for only few minutes. So yeah, by using the AI agent, you can easily to understand all of the project. So even though there is no document, from the source code you can understand the project. And currently, in order to modernize the system, we can analyze the current system and the current project. So finally, I would like to modernize the application by using the AI agent. So migrating user natural language. This is also, I use the GitHub Copilot editing with the AI agent. So in order to do that, I created the prompt like this. So current state is implemented with the Java SE 6 and Java EE 6, and using the Java X package instead of the Jakarta package, and dependency in the pom.xml are outdated. So task to address is transition the JAXB component dependency in Java EE to Jakarta XML binding, and change package name from the JavaX Jakarta, and updated all dependencies library in pom.xml to the newer version compatible with the Java EE and the Jakarta EE10. And instruction is please migrate from the Java EE6 to the Java EE10 with the Java SE11 by using the above migration point. So currently I'm using the I'm preparing the Java SE6 and the Java E6 project, and by using this project, I provide this prompt. In this time, I also use the Claude 3.7 Sonnet, and I change the agent mode, and I provide the prompt to the AI agent. And if I executed this prompt, then it automatically agent will considering what should AI do, and in order to upgrade the system, what kind of process is needed automatically. AI is considering, and so AI agent edit mode is automatically updated the XML file and all of the source code file. So look like this. So this is a change from the AI, and if you click and if you check, so you can detect which kind of point has upgraded and modified. You can understand, and so look like this. So automatically AI is considering and automatically upgrading the XML file and the source code. This is XML file upgraded, and not only the XML, but also look like please see this. So after detected the source code change is needed, so AI is automatically change the source code. So in this time, the Java X package name is old, and AI is automatically upgrades the package name to the Jakarta. So look like this automatically, continuously upgraded the source code. So look like this. So at first, you can provide the prompt to the AI, and after that, I provide the Hue prompt to the AI. As a result, this is actually created the change from the AI. So by using the AI agent, I change. Look like the sorry. So look like change is automatically upgraded by the AI, and not only the source code, but also look like this. So XML code is also upgraded. So because the namespace of the XML schema has changed to the it will also change from the AI agent automatically. So it means that if you use the so AI agent. So maybe so it will be very, very useful. And it will just under the 1 hour to build successfully compile. So no, so more detailed analysis and test is needed for the production. However, so to complete the compile, so only 1 hour. Furthermore, so for the Spring developers and another tool, so GitHub Copilot upgraded assistance for Java is available, and more detail will be provided by the next session. So please see the next session. And also in this time, so there's no time. However, so GitHub Copilot workspaces is very, very also useful. So please try to use the GitHub Copilot workspace too. Yeah. So this is the なんだっけなんだっけ It's a finish of my session. Thank you so much for joining.
Yosha, thank you so much. And I love the fact that you actually introduced our next speaker, which I work with also, Nick Zhu. And we've got an incredible talk that we're going to be speaking on, and Amanda Silver even covered him. So Yosha, thank you so much. Nick, I want to introduce you. And if people don't know you, you are the kingmaker. Like every time that we meet there, you show me some new tools, new toys, and I go, oh, and my face drops down there. And I look forward to our sessions there. So I'm hoping that I learned something new today. I know that I will. With the Upgrade Wizard, we had Open Rewrite already speak. We had Yosha also showcase though. So I'm going to hand it over to you. You have limited time to wow us around this also though. So over to you, Nick, and I'll see you at the end of your talk.
Yeah. Just self-introduction. I'm Nick. I'm the product manager for GitHub Copilot Upgrade Assist for Java. Our team also owns the GitHub Copilot for JetBrains, Eclipse, and Xcode. So today I'll be sharing the session and do a deep dive into the GitHub Copilot Upgrade Assistant for Java. Like usual, already did a sneak peek into this product. This is an AI-based solution to help Java enterprises and upgrade their Java apps, runtimes, and frameworks. This solution is based on a multi-agent framework and basically provides the developers to upgrade the Java apps with trust and transparency. But before we show the product, I want to just talk a little bit about why we need to upgrade the Java applications. Obviously, we all know that we are moving to the modern cloud-native applications, such as microservices, enabling all the modern architecture, such as scalable patterns. But there are some important details, such as when we are moving to higher JDKs, we're enabling new features and API. And a lot of enterprises actually mention very important things, such as security updates and patches. And also when we update third-party libraries and JDKs, we can also enjoy the benefits of improved performance. And as we all know that as we deprecate old JDKs, we are also need to have extended support for the new JDKs. And also for the community ecosystem, we also need to upgrade it to the later versions of the libraries. And of course, I think the one thing that we also need to remind us as we develop new features is that we need to reduce the tech debt in our code base at all time. So these are the things motivation factors when we think about why we need to upgrade our Java applications. But all of the things, when we do that, we actually could pose a lot of challenges, right? Because Java is a language with a lot of history. So some of those code bases can actually be very, very complex. And when we're upgrading JDK, which is the major tasks, there could be a lot of dependencies actually not compatible with the latest JDK and API. So when we do the JDK upgrade, we actually have to update a lot of frameworks together. So that actually is a huge chunk of work when we are upgrading the JDK together. And also frameworks like Spring Boot often result in configuration changes. And of course, when we upgraded those code bases, we also need to upgrade the unit test. So these kind of things could break, and we may face regression of our projects. And not to mention some of the old projects, they may have very low test coverage. So in enterprises, we kind of face the balance between developing new features and maintaining the tech debt. So we'll have to face resource allocation challenges. So upgrading these things are tedious and takes a lot of resources. And these are not fun to work on. So we also have to see downtimes of the project, learning curves, and so much more. So those are all the challenges when we are upgrading Java applications. So what can we do to reduce kind of complex tasks? So that's why the AI kind of here is to help us deal with open-ended tasks like this. So today, the agent, I think many of the people here probably have heard about this word. So many in this year. Agents actually can deal with these kind of complex tasks more and more, and because it has the ability to divide the most complex tasks into several phases. So first, it actually can provide a big task into several smaller tasks, because he has the ability to do some kind of task planning. And then with the correct level of prompt engineering and the logics, it actually can derive the most reasonable tasks into the most reasonable steps. And also during the upgrade process, it can utilize different kind of tools. For example, in Java projects, we have the Maven and Gradle, and we also have an open source tool called OpenWrite. And agents can actually have sub-agents as well. And during the process, it can self-fix issues. And so it has the ability to handle errors. We can also utilize memory and to store context. And then we can also let the agents interact with human developers to manually intervene and fix errors if necessary. And for these kind of tasks, we can also set up some kind of evaluation system to make sure the agent perform at a very high level. And the last but not least, we can have human-agent interaction, like I just mentioned, and agent can interact with agent themselves. So these are the things that how AI can help us to deal with complex tasks with upgrade like this. So Java upgrade is not a huge thing that human developers have to deal with themselves anymore. So with that being said, let me show a quick demo of how this product works. So this is a case where we upgrade the Java app from Java 8 to Java 21. So currently, the product is a VS Code extension. So imagine I'm a Java developer. I'm starting an extension, starting from the VS Code extension and upgrading from 8 to 21. First, we need to specify some parameters. So here I'm selecting the current and target Java version. And now I'm just selecting the parameters here. And this is a Maven project. So we can see the build tool and the Java parameters already analyzed from the current workspace. So here I click on the create plan. Now the AI will kind of analyze the dependency and frameworks in the current project. So I have the Spring Boot framework in the current project. And then it's also recommending us to upgrade the Spring Boot framework as well. And then because it's not compatible with Java 21, so I'm just confirming it's upgrading to 3.2. So as part of the upgrade process, I can also run unit test cases to validate my upgrade. Then you can see the upgrade plan is generated with several steps. So I review this plan and everything's good. I click on Start Upgrading. So now the assistant enters several steps in this execution phase. So in the first task, I actually just kind of verify everything is good to see the project's in a good state. In this process, I just kind of build the project using the Maven command and run the unit tests. Now in the second task, actually this assistant will run an open source tool called OpenWrite to apply the code transformation. And we can see the assistant actually selects the recipe intelligently because we are upgrading to Java 21 and we are upgrading to Spring Boot 3.2 as well. And the developer can actually directly click on the recipe to see the details. Now the second task is completed. We'll enter the third task, which is to check and fix any remaining errors. Because OpenWrite step might not fix all the issues, and we can see that there are still errors remaining in this project. So this is where the AI comes in and fix issues for us automatically. We can see that there are still issues, and we can directly see the error details in this dashboard. So this is where actually we're entering a dynamic build fix loop where the Copilot continuously to build a project and fix errors. So this will repeat a few steps until it finally succeeded. So let us, this will kind of run for a few steps. Oops, yeah, let me go back to where the video begins. Okay, now all the issues has been fixed with the AI. So the last task is to verify the project is in a good state. So we can see that it's running the unit test. And the last phase is actually the summary phase. So here in this screen, we are seeing all the updated dependencies and unit test cases status. So we can see before and after upgrading all the test cases, there are no new failures and errors. That means we have not introduced any new issues. And also in the dependencies part, we can see all the changes. And in the third-party frameworks and JDKs, we can see it very clearly in the list. We can, in the error resolution summary, we can also see how the errors were being fixed. So we see that the AI actually addressed 3 issues for us. And also in the review changes button, if the user clicks on it, we can directly see the code diff. So this allows us to see what kind of changes being made by the AI and what kind of changes were made by the OpenWrite tool. And each commit is associated with the task. And also in each step, there's also user can also see the logs and outputs. So let me just go back a little bit. So at the end of upgrade, the user can also click on generate unit test cases. This feature is for code bases that has low test coverage. So we'll actually allow users to generate additional unit test cases. This will kind of generate a pop-up, and we can see that the unit test case is being generated on the top left graph panel. We can see. Just let me go back a little bit. Yeah, here we can see that the changes are in the source control panel. Yeah, so let me go to the report. Yeah, so after the user test cases are generated, we can see the report. And then we can also see how many test cases are generated and the pass rate and everything is published in this report. So that's also another feature that we provided for the enterprise to use, and also in this graph, the user can directly click on it to see the generated unit test cases. Yeah, and finally, if everything is good, the user can click on the merge changes to merge all these changes into the local branch. Yeah, so that's the demo. So we provide the complete end-to-end flow for the Java upgrade, as well as the unit test case generation. Okay. And then to just summarize some of the features I just showed, this product is kind of divided into 3 phases. In the planning phase, the assistant analyzes the project, assess dependencies, and propose an upgrade plan. In the execution, it automatically transforms the code, fix issues during the upgrade, and if the developer needs to address some errors, it will actually allows you to make some interaction, and you can see that it's running the unit test cases during the upgrade. And at the end of upgrade, it can also generate unit test cases. And lastly, in the summary phase, you can review all the changes and outputs, and you can choose to merge the code changes. So the product is currently in a technical preview, and this is the QR code to join the waitlist. And we select the customers on a case-by-case basis. Yep. So, and the last but not least, we have a complete product portfolio to meet some of their modernization needs for the customers. I think as Yushu mentioned, actually we have another product called Azure Migrate to kind of assess the needs of the product to, if you ever need to migrate to Azure. This is more on the migration side. And we also have GitHub Copilot upgrade assist from Java for .NET to actually do the upgrade and modernization scenarios. Yep. So that's all for the content and demo. Yep. Back to you, Rory.
We're on time. We're actually ahead of time, which is great news. So now we can eat into some of that time. Because, if you watch these talks, though, it's like speaker, stop, speaker, stop, speaker, stop. So thank you so much, Nick, though. And, I think one of the themes that we've done today is really highlight how easy it is now to go in and take a legacy application. In some of the comments, I saw Martin even saying that he had to kind of have a conversation with the AI and everything. But this is more than AI. This is also using Open Rewrite. This is scanning your application source tree. It's using some deterministic procedures also, though. So it's a great opportunity for you to go in to your project, your legacy project, run it, and then also, Nick, feedback to you, to your team, to make sure that they understand, wait, what is the issues? Did you have an issue? If not, do they love you? And to send kudos to that, though. So excellent talk. Just before we go, you go, and I want to bring on Ed onto the screen. Ed, if you're there.
Hello, Rory. How you doing?
Hi,
I'm great, and great news is that I started at 4 a.m. I'm 2 Red Bulls down though, so I'm a little bit hyperactive, but also very caffeinated up though. We have two of your speakers. You're going to be speaking with yourself, and then there is another. I'm not going to butcher their name right now, though. So I want to introduce you and your talk. You're going to be speaking on Hyperscale. Always a great CFP when you start up with Hyperscale. Hyperscale PaaS for any Java app. Okay, so we've got two buzzwords there, and we're really gearing up for some hyper excitement. I want to say cheers, Nick. Thank you so much for the talk, though. Ed, we are ahead of time, so if you want to start now, or alternatively, we can chit-chat for a while.
Let's have some chit-chat. Is that all right?
That is really cool. I'm paid to chit-chat. I actually have a certification of the chat, though. One of the things that I'm really interested is that everyone now with AI, with agents, especially with Jakarta EE, they're trying their best to almost not hardwire, but retrofit everything to AI. We had a session earlier today where they showcased using Jakarta EE. We had Basler and Saeed talk about it, though. What is your take on where the industry is going with AI? Is it just a buzzword, or is it going to provide actual value?
Absolutely. And I'm really happy to talk about this and also give a plug. So my colleague, Emmanuel Hugonet from Red Hat, has done an on-demand session for Jakarta EE here at JDConf, Jakarta EE with MCP. And he's talking about that. So when you're going through your JDConf roster, please make sure to search for his name, Emmanuel Hugonet, Hugonnet. And basically what he's doing there, and what I've been promoting myself, is that people look at Jakarta EE and they think, oh, they do standards, right? Well, they must do a standard for AI. Well, I know from deep and long painful experience that premature standardization is not a good thing. I've been spanked for that years ago with JSF, decades ago, actually. And so what we're doing with this project is to AI enable all of the things that you can do with Jakarta EE and not introduce a new specification, in fact. So the most exciting thing about it is when it comes to agentic, and it turns out LangChain4j, as you know, has had agentic AI for a long time, long before it was even called that, right? And this was the @tool annotation. And really, it's the same exact concept as you get with Anthropic's Model Context Protocol, where the AI is given a set of tools that it puts in its toolbox, and it decides, you know what? Here's something that, like, I need to cancel a booking, for example, for a car rental service, the canonical example. Well, then I'll call this method and let it do its thing and then come back. Now, the fun part is when you get called by AI, you now can take advantage of all of the features that Jakarta EE offers. Validation, injection of other kinds of things, and the many other APIs, transactions, whatever you have. There's like a gigantic raft of specifications that cover all of the feature set that you could possibly need for doing an enterprise app. And you can take advantage of those, but also have the benefits of agentic AI.
So one of the things that Microsoft does well is listen to its customers. And what you've said there also, we have a lot of Java customers. I just want to reiterate, we have a survey that I want to mention. It's on our, I think it's somewhere. I don't really.
Oh, you muted. We're back.
Okay, so it is our survey there. And one of the things that really we can do, especially with our Jakarta EE customers, is say to them, is this enough? Do you want more? And I would love to actually see exactly, are they riding the hype? Can they get through to it, though? So please snap that, go through the survey, and then fill out, wow, Rory's hair is really good. I even got a haircut for this session, though. So yeah, I see that your speaker's online also, your other speaker, though. So I want to go back on camera because now it's your time to shine, though. So I want to introduce the two of you, and I'm going to hand it over to you. Thank you for coming on early, though. We had some chit chat. Now you have a little bit more time, also, though. And then at the end of your talk, we'll say goodbye. Okay. Cheers.
Absolutely.
I'll
see you soon. Hello, my name is Ed Burns. I'm with Haisha Cheng, and Haisha is going to kick off the slides, and we'll get started. Just make sure you got the screen sharing going. We're ready to go. We're just working for the screen share. Here it comes. Yes. No, don't worry. Just switch it over. Take your time.
Okay, yeah, we seem to just need the screen share. So Ed, I'm here if you want to bounce anything off with me while Hyperscale gets it ready, though. At
Sure.
the same time,
well, let me talk about what we're doing here. To minimize the amount of back and forth we have to do during the presentation, we'll start with Haisha sharing her screen, and then I'll cover the second half. So we're going to be interactive in our speaking, but the screen sharing will be one thing. So yeah, and go back to the title slide. There you go. All right. So I'm going to be covering the content for the first part a little bit. We're going to be talking about Spring, Quarkus, Tomcat, JBoss EAP, Hyperscale, PaaS for any Java app. And let's code the future with AI together. So go ahead. A little bit about me. I've been doing software development for over 30 years now. Had the good fortune to start my career at the very beginning of the web, working as a student programmer on the very first graphical web browser ever brought into the world, and had this transition of moving from the client to the server and now to the cloud. And would like to bring out, as you're working through your career, we're in the midst now of another transition phase, which of course would be the AI phase. And I like to applaud you all for watching JDConf, because by doing so, you're being able to ride the crest instead of going underneath it. Aisha, go to the next slide, please. Oh, sorry, you're muted. Having some audio issues. Yeah, I can hear your audio. That's good. I can hear your computer audio, but the mic is not working. Don't worry about it. We're having some technical issues. We'll get through it. We want screen audio for sure, but the mic. No, I can't hear you yet. Nothing yet. Well, you can go back to the screen share and I will introduce you. And as I'm presenting my content, you can work on the unmuting of the audio. All right. Well, I guess.
Well, I'm back again. Okay. Yep. Well, you just can't get enough of me. So
no,
definitely want there. It doesn't help to not format and reload live on air, right? You take your Windows, it's licensed, you go into your
Rory, I think we are also having issues with you because we are unable to hear you.
Oh, I can hear Rory.
Yo, I can hear me. I'm loud as hell.
Yeah. So I guess I'll share the screen on my end, and then we'll try to get Haisha's audio challenges resolved live. So I will go ahead and give it to me again. and I will share the screen. Do you have it now, Hasha? Check audio. Not yet. Okay. I'll present. Share screen. Entire screen. Yes, please. All right. And can you all see my slides now? Yes, I guess you can. All right. I'll keep going and tell me if I'm doing something wrong. So we know you have plenty of other options to attend here with your time during JDConf. So our plan for your time investment is first, describe app service itself. We'll give you a brief history and cover the value proposition. Then we have the sample application. We'll show the code and give you an architectural overview. And then, true to the title, show any app. So these are the major stacks that is supported in app service. Now that last one there, actually the last two, Spring Boot and Quarkus, are being run from the Java SE side of things. And then finally, we'll come to our summary. This overview slide will show you the many different pathways you can have to get your Java app running on Azure. We're going to be covering this managed services pathway here, but we also have virtual machines, containers, and serverless, and all of those let you run Java in a very idiomatic way that you're used to with the app service container or the application server that you're most comfortable with. We realized at Microsoft that the expertise for running Java has been built for a very long time before the cloud came along. And these stack vendors really know how to run things well inside the JVM. So rather than reinventing things ourselves, we're partnering with Red Hat, IBM, and Oracle to bring these offers to you. Coming to App Service. Now, Azure App Service offers ease of use, ease of management and productivity, and lower TCO. Everyone likes to lower TCO. We provide all of these managed services for Java SE, JBoss EAP, and Tomcat for building blocks. Now, by doing that, we cover a pretty broad range of functionality just right there. On top of that, though, we give you Java bindings and tools integrations for the best-of-breed Microsoft software, also as managed services. So you can interact with your entire data tier, whether you're running PostgreSQL, SQL Server, or a document database, Cosmos DB, which has a MongoDB front end. If you'd like to put that on top of it, you can run your messaging queues and such, all of those services there as managed services. And really, App Service is the premier PaaS offering on Azure with specific support for all of those key Java stacks that I mentioned. Here's the sample application, and you can get it from my colleague Reza Rahman's GitHub. We are using VS Code to do the development and push a commit to GitHub, and then Maven is doing the deployment. And so we show JBoss, Tomcat, Spring, and Quarkus running there on App Service. And we're using Service Connector as the interaction fabric to handle all of the managed identities. Now, I like to bring out that Microsoft has a very long history of being a very secure platform, and that comes to the cloud as well. So our secure passwordless database interfaces are implemented using Service Connector to handle that managed identity coordination. And then we're using the PostgreSQL service as well. Now, on top of this, we need to enable you to use App Service with many different tools. So we have build plugins. We're going to meet you where you are, whether you're using Maven or Gradle. This demo is using Maven, but you can see we've got the wiki links there to the different pages for the different plugins for both Maven and Gradle. Or you can use the code to cloud feature inside the Azure portal. We won't show this in the demo, but I'll hit on it briefly just to show you where it is. You can basically tell using the Azure portal, here's my GitHub repo. Just watch this for when I make commits, and then you can build the code and run it. And of course, IDE support. We've been having lots of great talks about the IDEs, JetBrains, IntelliJ, VS Code. And so we have plugins for that, the app service extension for VS Code, the Azure Toolkit for IntelliJ, and we even now have Eclipse via Azure Toolkit for Eclipse, which is really, really exciting. We'll start out with JBoss EAP on app service. Now, let me make sure I've done the right thing to share the audio. This is something I need to check with StreamYard. Settings. I want to make sure I get some help to make sure that my audio plays, because I'm about to play a video. And automatically adjust mic volume. I'm just checking to see here if when I play the video, the audio will come across. And Molly, are you able to help me with that?
Hi, Ed. You can play the video, and I'm right here in the background, so I will let you know.
Let me know if the audio comes through right.
Yes.
So here it is. Slideshow, play from current slide, and let's play it. I'm not hearing
all for business success, but they exist on premises, locked inside of infrastructure that is expensive to maintain and difficult to scale. You want to preserve your app server investments, but lack the time and IT staff to move and manage. Red Hat JBoss Enterprise Application Platform on Microsoft Azure offers the flexibility needed for building, deploying, and managing your Java applications in a cloud environment. JBoss EAP on Microsoft Azure App Service is a fully managed, jointly supported platform that increases developer productivity while reducing operational costs and time to market. Organizations can tap into all the benefits of a cloud-based architecture to modernize their existing Jakarta EE applications with features for auto-scaling, monitoring, and security, easier integration with a wide range of Azure services for messaging, data, business intelligence, and more, and a single, flexible, and convenient pricing structure with integrated support from Red Hat and Microsoft. Get automated alerts for application infrastructure issues. And because it's a managed service, eliminate the time, cost, and pain associated with deploying, configuring, and updating virtual machines. JBoss EAP on Azure App Service simplifies the developer and IT operations typically required for Jakarta EE applications. On-demand, pay-as-you-go pricing means enterprises don't have to purchase a subscription. They can simply create a JBoss EAP service on Azure and start deploying Jakarta EE applications right away, paying for only what they need, and receive integrated support by Microsoft and Red Hat. Microsoft and Red Hat are committed to driving Java forward, with a strong partner ecosystem that provides best-in-class solutions to extend the functionality of Java applications. For organizations and developers that want to focus on their applications instead of managing and configuring infrastructure. For those looking for a seamless experience running Java apps in the cloud. And an open platform that provides developer tooling, fully managed platform services, and an extensive set of partner offerings. There's Red Hat JBoss EAP on Azure App Service. Ready to get started? Contact us today.
All right. Well, let's see if Haisha is able to get her audio problem solved. We'll go back to the StreamYard, and we'll ask if you can bring in Haisha. Hello? No, we still can't hear you. Okay. All right. Let's see. Should we try to troubleshoot this some more, or should I just keep going myself? Because I would hate to bulldoze over all of the nice content you had prepared. Maybe you could actually, you want to try leaving the StreamYard and coming back in? All right, let's try that. And we'll get Rory back on, and maybe we'll do some more. There he is, my man.
Understand, but while you're doing this, I'm busy chatting to a few agents in the background, though.
Right.
This is how advanced agents is. I'm doing a presentation on Azure Container Apps security issues with it, and I'm chatting to. I'm not going to mention the agents though, but they pulled out everything. They said quack 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 quack. They gave me images. They gave me a PowerPoint and everything. And I'm not saying that like I'm 10x AI person though,
right?
But it's incredible that I can just do that. Like your talk right here, I can code and I can vibe code what you're talking about me live on air with it just by having a conversation.
Yeah, that's cool. Now I want to put out an idea, and I'd like to see if this exists, and I'd be surprised if it isn't. Many people, I'm in the midst of a Jug tour, right? I'm speaking to lots of Java user groups in Germany right now. And tomorrow's my last, actually today is my last day. It's not tomorrow, it's today. Anyhow, I've asked a lot of people, hey, have you ever come to a GitHub project and found that the README is out of date? And yes, a lot of people say, yeah, sure it is. Well, why don't we have a CI/CD enabled thing like Dependabot, where when you push a commit, it looks at your code and automatically updates the README. Because if you've made any changes that invalidate the text that's in the README, it would be a way to keep it automatically up to date. So it would include that file in your pull request, and you'd actually be able to review it and say, yes, yes, yes. So we've reached the point now where you can come up with an idea, and then it's probably already existing, And if it isn't already existing, I'm hoping someone listening to this StreamYard.
That's not the biggest issue, Ed. The biggest issue is that which model we're going to use. Because, oh my gosh, every day a new model comes out and I want to try them all, and everyone is better than, just when I think I've settled on a model that I like, someone else comes with another one and I go, And there's subtle nuances to those models that you have to really see though. And I think that, yeah, definitely that's an opportunity for people to do. But the biggest problem is we're just spoiled right now. We really, really are spoiled.
Spoiled for choice, sure. Mm-hmm.
I myself am a big fan of the models that have been trained to understand code. So there's some models that have been trained to understand code. Yeah, you get the big ones, the big models that can recite Shakespeare. But I don't want Shakespeare. I want code. And I want to be able to have syntax correct. I want to also, not always go down to PowerShell when I want Bash, or Bash when I want PowerShell. I want the correct code though. So I have noticed that there's a huge industry now that is bringing out these models just trained on code.
I changed my computer, so
yes.
you can.
Oh,
thank you.
I know your heart's probably beating very fast, but it's.
Let me set my background, okay?
Yep.
We set the background. Give me.
Right. Reporting live from the Shanghai office from Microsoft. And I'm glad we got the audio problem resolved. And once you get the background set, you can go ahead and get started. Okay, another thing that Roy was talking about regarding models, there is a really nifty website called SWE Bench that lists leaderboards for these different kinds of models, and you can look at the leaderboards and see how well they're doing against a set of programming tasks. Now, the programming tasks in the SWE Bench are built using Python, not Java, unfortunately. However, the point of the SWE Bench is to basically say, look, we're going to compare apples to apples with regard to the capabilities of the model in terms of reasoning for code. Are you familiar with SWE Bench?
That's another issue, though, Ed. There's so many benchmarks now. So not only are there models, though, but now I've got all of these benchmarks, though, and I got. Do you know that we have one on Foundry? Azure Foundry. I log in there, and it gives me a benchmark.
It's true. There is a leaderboard there, right?
Yeah, but like, which one do I? Who's because it might be opinionated. It might be, you know, and I want a code leaderboard. Okay, code, just nothing else.
Yeah. Hi, Shai, are you there?
Yeah, I'm here.
So, go ahead.
Yeah, so I will start from sharing the demo. Okay, all right.
Yep.
Okay, let me share my screen. I will share with the entire screen. Yeah.
Don't cut away. We're going to do it.
Yeah. Give me 1 second.
Yep. I'm just telling the production people, don't cut away. Yeah, you won't be able to see the StreamYard at the same time. So you just go ahead and share your screen.
Window. I think you can see my screen now, maybe. Oh.
Go ahead. And don't worry about the window. It'll go away when you switch to a different task.
Oh, yeah? So
yes.
Now, let me go through our demo quickly. Yeah, you know, now we are trying to deploy the multi Java runtime to the app service. I just use the demo to show how it is how simple it is to deploy the application to the remote app server from the development environment. Yeah, our sample contain 4 runtime. One is the JBoss and the Tomcat and Spring Boot and the Quarkus. They share. They serve as the back end of the sample, and they share the front end. The front end is written with the Node.js. So now let me show you how easy it is to run the application on the JBoss. Let me show you the JBoss. I have prepared the. I have to log in. I have set up the resource in my subscription. Yeah. Now let's have a look at the resource. Okay. Before sharing the resource, I would like to show you a quick structure of the source code. Yeah, I asked the GitHub Copilot to summarize the source code, and now I'm sharing the JBoss one. The application is running on JBoss EAP8, and it used the PostgreSQL as the database and use the JPA for data access. Yeah, now let's have a chat. Yeah, this is the JBoss app service. Let's check the runtime. Yeah, the Java 17 and JBoss. Okay, now let me now for the service connection, we leverage the service connector to use the Azure Managed Identity to connect to the database without using the password. So it's very convenient to set up the connection. Yeah, I have set up that, and we just need to enable the connection stream using the environment variable. Now I will try to deploy the app to the remote server. Let's see how. Yeah, I previewed the application before the meeting, so it can save some time. Yeah, now the main one is building the front end and copy the front end and package to the front end to the RAR file, and now it is trying to deploy the application to web app. This is using the Azure the Maven plugin to achieve that. So now we can check the log to see what happened in the remote side. Okay, so we can have a live log stream. We can get the live log from here and observe the process of the deployment. So it's very convenient if you are developing the application and you want to try it on the remote side and see how it works, and then you can monitor the log. Yeah. It will take the remote side will set up the JBoss EAP one time, so we don't have to set up it manually, and it will set up the database connection for us. So it's very simple to configure the application. Okay. Now the JBoss is creating the database. Okay, let's have a Okay, now let's have a look at the Maven plugin will output the URL to access the application. Let me check that. Open the application. Oh, yeah, it is here now. Yeah, I want to have this item. Yeah, so the application is running on the JBoss EAP 8 on the app service now, and with the database connection enabled. So the next, then I will share you the Tomcat one. I try to use the Tomcat to create a backend, and I try to deploy the backend to the application to the Tomcat one time. So now I have the Tomcat set up. I'm using the Tomcat. Let me check the Tomcat one time. It should be 10.1. The latest version should be 11. Yeah, I'm using the Tomcat 10 and using the Java 17. Also, I use the service connector for the database connection. So now let's deploy the application to the Tomcat. Okay, I have to go back to Tomcat. Yeah, I use the same command. It's very easy. Yeah, I use the Azure Web App my Maven plugin. Now the plugin is the application is built and packaged, and now okay, start deploying. Now let's check the log of the Tomcat side. Oh, so when you have any change on your application, then you can very easy to kick off the deployment using the command. So it's very convenient for a developer to observe the behavior of my application. Yeah, so let's double check the log. Okay, it starts deploying. This is a very small error, broken pipe. Okay, we can ignore it now. It will not
right,
stop
but
the
you can see
deploying.
that
Yeah.
this is showing the functionality of the live log streaming. So for quick production troubleshooting, it's actually really good. I also observed that App Service has made some really great advances in the live troubleshooting aspect that we're not going to demo here. But if you look into the Copilot for Azure, there if you're signed into the Azure portal, you'll get a Copilot button. And if your account is enabled for that, I don't see it on Haisha's end, but it lets you troubleshoot things live with Copilot as an assistant in the Azure portal.
Yeah. So now the deployment has been finished. So let's check the, they are the same. Yeah. We use different database. So this is a new item. Yeah, that's very easy, right? So I will recommend as a developer, I'm really happy to recommend this service for our customer. Yeah, that's all for my demo.
All right.
I will stop sharing.
All right, I'm gonna go ahead and share my screen, present. Where did it stop screen? Present, share screen, here we go. And entire screen, select this and share. All right, I am sharing my screen. So if you're gonna bring it up for StreamYard, there it is. And let's go over to the demo for Spring Boot. We can't really say we're running any Java app without being running of Spring. Spring, of course, is a hugely important part of the Java ecosystem and also uses many Jakarta EE APIs. All right, so I've got the demo up here in Visual Studio Code. This is the same repository as we were showing before. I'm in the Spring Boot directory, and I'll observe that we were talking about using the Azure Web App Maven plugin. In the plugin configuration, this is where you can specify all of the properties that you need to configure your application. We're using Java 17 here, but 21 is supported, I'm happy to report. And I'm pointing to the resource group. You can pull that from a property if you like as well. So let's just do the Maven clean package Azure Web App deploy. And while that's running, I will open up GitHub Copilot and ask it to talk about the same exact thing that we did here. I had primed it, tell me about this application. So it's a Spring Boot application with a backend architecture. It exposes the following REST endpoints, and it gives you an overview of the local and Azure deployment. So all of this is read by the GitHub Copilot. You can choose your different models. I'm using Claude Sonnet because that's the one I like at the moment, but it might change, right? We have these leaderboards, so we can pick a different model. So it's picking up my subscription. And while it's going, I'll switch over to the portal. There we are. And here, this is my resource group where I have things deployed. And I'll scroll down to log stream. We should see this going also. There we go, connected to the log stream. And while this is also going, we've got that. Let me pull up the Copilot in the Azure portal and let's ask it. Okay, not now. Okay, starting live log stream. So I'll ask this. I am using app service. Where in the Azure portal can I specify a GitHub repo for deploying code to cloud? And while that's going, okay, completed initialization. We're still going here. Let's see if my terminal is done. Build success. Yes, and here's the application URL. So let me open this, open the URL. And so I can say, demonstrate Spring Boot functionality. Yes, item added successfully. I'll click this. It's done. Back to the portal. Not that one. This one. Yeah, here we are. Okay, so let's see. Navigate to the portal. In the left menu, select Deployment Center. Under Settings, choose GitHub as your source. So let's test it out here. I'm not going to actually deploy it, but Deployment Center. There it is. Great. So using Copilot inside of the Azure portal solved my problem. It directed me to where it is. And this is loading. Right. Select code source would be GitHub. And you could pick my organization. It's, I think it's Azure Java EE. Well, I'll do it Ed Burns. There. And you can pick from your repositories. And I've got a ton of them, of course. So if I had this one cloned into my own repo, I'd be able to point to it there and deploy it. And you can even specify a branch, and then you can pick your runtime stack, and it's really awesome. So you can go straight from code to cloud. Next up on the demo list is, let's see, go back to my slides. Quarkus. All right, Quarkus is a super popular runtime from Red Hat. It is a cloud-native Java runtime. And in contrast to Spring Boot, which is a layer that came on top of the Spring framework, which was not exactly cloud native, but they made it more cloud native with Spring Boot. Quarkus, on the other hand, was started in 2019, so it is fully cloud native and has its own set of plugins. So let's see how we're implementing that. So I'm going to quit code and open it up again into the Quarkus directory, QUAR, there you go, code dot. And let's open up, you can see there, we're using the uberjar package type. So this is running on the Tomcat, I'm sorry, the Java SE version of app service. So if we select the POM and search for resource group, there we are. Here is the one that we're doing. Yes. And I'll run the same command as before. Let's open a new terminal. And while it's running, I'll do a little bit of more explanation. Azure Clean Package, Maven Clean Package, Azure Web App Deploy. Scanning the projects. And okay, it's going to run. Now, this one is interesting because Quarkus, of course, has its own Maven plugin. So we're using kind of a combination of things here. We're using the Azure Web App Maven plugin to handle the Azure deployment portion. But if you're wanting to run it locally, you can use Maven Quarkus Dev. And there is a lot of great documentation out there for the Quarkus Maven plugin. The functionality of the application is the same as before. So let's go over to the portal and see how things are streaming along. We're in the StreamYard and we're streaming. There we go. Here's my resource group. I'm going to not deploy this. And let's another instance of app service and the same app service plan. And down to log stream, connecting. Let's close this tab here. Okay, and back to the terminal. All right, it's deploying using the jar runner. Okay. Oh, and we can see there already is some activity on this deploy async. So this is showing me it's using Hibernate and Panache. Panache is the ORM layer of inside of Quarkus. And let's go back.
So
to code.
Ed,
yes,
I know that we had some excitement during the talk, but we do have our next speaker. So this is just me.
Well, all right. Let me click this. Can I? Is this like my 2-minute warning?
Yeah. Carry on until the other speaker, until they do that though.
I've got 2 things left. Zero, demonstrate Quarkus on app service. And I can check that off as done. And I want to leave you with a few lessons here. One, which is super powerful, is that now you've got GitHub in your Copilot in your IDE. You can learn more about the code that you're working with. So if I could ask it here, and I'm not going to, I'm just going to put the query out there. How is Panache used in this app? So any good presentation to them with a message, a call to action of how to do things. So there's two actually here. One is don't be afraid to use GitHub Copilot in your IDE because it will let you learn more about the code you're developing. The second is app service is the best and only Java PaaS on any hyperscale cloud. We give you coverage for the most popular enterprise Java workloads. We have a full suite of tool support. It's also very easy to use, as I've shown. And I'd like you to take some time to fill out this survey here. This is, we're hitting you with lots of surveys.
Oh, that's going to be popular. That's going to,
Yep.
you mentioned $100 gift card and
Right.
oh.
So get on that. This is the survey I've been using during my 7-city German Java user group tour, which I'm completing tonight. And it's a custom designed survey to cover the app workloads that we're working on here today. So thank you everyone. And we'll take it away.
And everyone roots for everyone to make sure that the session went great. It went great. And we've got a incredible session afterwards. You want to stay on here. It's the Paketo Buildpacks for Java containers run by Anthony and David. So I'm not going to talk anymore. You can play their session though, and let's go watch some Paketo Buildpacks with Anthony and David.
Hello, welcome everybody to this session about Paketo Buildpacks. Are they the best way to build Java container images? I am Anthony Dan, and I am a software developer. I'm working for Broadcom inside the Tenzu division that is in charge of maintaining the Buildpacks. And more particularly, I am in the Java Buildpacks team along with David. Hello, David.
Hello.
Okay, so without further ado, let's get us started with today's presentation. Of course, we are going to talk about Buildpacks, and first we're going to define them. Then there's a very frequent questions about Buildpacks. Is it worth it? Are they worth it compared to Dockerfile? Are you supposed to migrate away from Dockerfiles? And then we'll see how and where you can use the Buildpacks. Okay, so what are Buildpacks, David?
Okay, so Buildpacks at a high level take your source code and turn them into container images that are ready to run your app. Buildpack itself is essentially a set of two binaries, one called detect and one called build. The detect binary basically determines whether the Buildpack should proceed in the build stage. So for example, the detect binary for the Maven Buildpack will, among other things, check for the presence of a pom.xml, and that will mean that Maven will be used to build this app in the build stage. The detect binary for the executable jar, as another example, will determine whether a jar is going to be the output of your build, and if so, it'll set the start command to java-jar and your app, as you can see on the top here. So the build binary then, this is the binary that does the chunk of work to actually build your app. It performs a number of steps like setting environment variables, downloading dependencies, and contributing the layers for the container image. So we can see some sample output here from the build binary phase. The first one is the JVM vendor Buildpack. This will install a JDK, a JRE, and the native image toolkit if you're doing native builds. In the case of a Maven app, this will install a JDK just for the build to do the actual compilation, and then the JRE will end up in the final runtime image. The next one then is the Maven Buildpack that I mentioned. this will check for Maven on the path or look for a Maven wrapper script. If Maven isn't found, it'll install it for you. Okay, so where did Buildpacks come from? They've had a number of iterations over the years, the earliest being by Heroku back in 2011. Then there was a second iteration by both Pivotal and Heroku for their platform as a service offerings in around 2014. And the one we're talking about today is Cloud Native Buildpacks iteration, which was formed by Pivotal and Heroku in 2018. The concept of Buildpacks isn't specific to these companies. You can create your own. There's other examples. You can even use your own custom shell scripts as the binaries. Okay, so the core Buildpacks project is part of the Cloud Native Computing Foundation. So while it has contributors from a number of companies as well as individuals, it doesn't belong to any one company. This project is responsible for publishing two pieces of software. The first one is a CLI, which is called the PaaS CLI. This is the CLI at your application directory to do the build. The next piece of software is the lifecycle binary. This orchestrates the running of the build, so it runs the detect and build binaries in phases that I mentioned before. The next thing that the project publishes is the spec or specification, which is like a contract that defines the interactions between an application, a build pack, and the platform that it's running on. Okay, so what we're talking about today is the Paketo Buildpacks project, which is part of the Cloud Foundry Foundation. And this is an implementation of the spec that I mentioned in the previous slide. So this also has contributors from a number of companies and individuals, and it publishes a range of build packs that support building applications in the languages you can see on the right. These include VM vendor build packs to supply the JRE, build system build packs like Maven and Gradle, and even a number of APM build packs that supply monitoring agents for the popular frameworks like AppDynamics, Datadog, and so on. Okay, so over to Anthony to show us the differences between building with build packs and a Docker file.
Yes, thank you, David. So now that we know that Paketo Buildpacks are definitely capable of building your container image, why should you migrate away from the Dockerfile, right? Because at the end of the day, Dockerfile has been there for more than 10 years now, and all the developers are kind of familiar to its format. For example, here we have an image definition that is based on the OpenJDK base image. There's no version there, so basically it's going to take latest. That's not a great thing, but oftentimes this is what we find. And then the user here, the developer, is saying that they want to copy something that looks like an executable jar, so apprunner.jar, inside the image. Then we set some metadata, workdir, and also the port that will be interesting to listen to. Then we have a combination of an entry point, java-jar, and a command that's going to, basically, when you're going to run this container image, it will just do java-jar and then the jar name, right? So this is what was expected. How would you do this using Buildpacks? Well, you would, for example, use the PaaS CLI, which is the default implementation. So you would use the PaaS CLI with the build verb, give the name of your container image, and then you would specify a builder. So here, this is a Jammy-based builder, but you could also set another one. And of course, you could have a default builder. So you wouldn't even need to specify the builder. Anyways, what does that do? It's not just simply java-jar that's going to be generated using Paketo Buildpacks. Why? It's because Paketo Buildpacks, they contribute many more things than just the app, the build app, and the JVM. For example, here we can see that the Paketo Buildpacks embed a memory calculator but it's smart enough, for example, to distinguish whether you're using a reactive application or not. If it's a reactive app, maybe you don't need as many threads as a regular app, for example. You can also see that there is the mention of something that deals with CS certificate and that can actually add them to the trust store. We'll see that in the next slide. And also, like David, you mentioned earlier on, there is a Spring Boot build pack participating, and that could actually inject a library to help with automating the configuration for a data source, for example. Okay, are there any other advantages, you may ask? Yeah, let's go back to the custom CS certificate case. So for example, if you are in a development shop where you have your own custom authority, then probably you will want to actually propagate the public certificate of this authority. Okay, pretty standard stuff. So once again, with a Docker file, you would use kind of the same code as before, except that this time you will need to run the key tool during your build. So the key tool will probably import your public certificate, and then you'll be done with it, right? What would you do using the Paketo Buildpacks? You would have roughly the same command as before, except this time you would just provide a binding. So basically, there are Docker volumes. And then thanks to this binding, the Buildpack would know that, okay, we need to have a look inside this folder, CSS folder, and then from this folder, it will be looking for public certificates to add. There's no mention of key tool or whatever. It's just the CS certificate Buildpack that will know what to do in your case. Where that comes super handy is when basically you have to build projects in different languages. For example, here I have a Docker file for a Golang app. And as you can see, dealing with certificates in Golang or even Node.js is quite different from Java. So when your teams would actually write Docker files for all their applications to integrate the public certificate, they will need to actually maintain very different Docker files at the end of the day. But guess what? Using Buildpacks, they would always provide exactly the same command. Why? Because once again, we delegate the addition of the public certificate to the Paketo Buildpack named CS certificate, and it's the same, and it's the same Buildpack across all languages. It just understands how to do that in different languages. What about software bill of material, VSBOM? Well, guess what? Using Paketo Buildpacks, once again, you're covered. Each Buildpack will have the opportunity to contribute a part of VSBOM. And the great thing about the Buildpack contributing to VSBOM is that each Buildpack has access to the source code it builds with. That means that they won't need to actually code anything in the case, for example, of Golang or Rust when you actually create a binary. Well, then they have access at the source code of those projects, so they are actually able to give you a precise indication of what are the versions of all the dependencies that are being used. So this is much richer compared to a solution where you would need to introspect a build container image, where probably the source code wouldn't be there, so you wouldn't have as much information. So this is quite an advantage of dealing with SBOM during the creation of your image. Also, the Pack CLI provides an SBOM command that allows you to retrieve this information also. Then one last point that we would like to mention as an advantage for the Buildpacks is that Paketo Buildpacks, like David, you mentioned earlier on, they also, well, the Paketo Buildpacks also includes some APM integration. So they are basically agents for providers such as Neuralink, Datadog, AppDynamics, and so on and so forth, and even the open source OpenTelemetry. So what does that mean? It means that easily, when you invoke a pack build, you can actually enable the inclusion of these agents, sometimes just with an environment variable, such as with Datadog Buildpack, or sometimes using some configuration, the configuration that would be mandatory for this agent. Here in the Datadog example, to build and make sure that the agent will be there inside the image, we are just enabling this environment variable. And then at runtime, whether you're using Docker or you're using Kubernetes to run your container image, then you would just need to provide the additional configuration, once again, with environment variable or a specific piece of configuration. Pretty easy, man. Okay, we have some demo ready for you, and we're going to build an app directly created from the Spring initializer at start.spring.io. We're going to build it twice, one using the Buildpacks CLI and once using another Buildpack capable solution, which is the Spring Boot Maven and or Gradle plugin. Let's have a look. I hand it over to you, David.
Okay, so let's take a look at a sample Maven app here, and we'll run the pack build command. So all you need to do is give a name to your container image, give it a builder, which is the thing that contains the build packs, and then point it to your application directory. So the pack CLI will run the detect and build binaries that I mentioned before in phases. You can see them running here. There's the Maven build pack that will do the build. Executable jar build pack sets the entry point or the start command, and then we can see the app container image being exported. Okay, app built successfully. So now we can run it with Docker run. Just give the app name. And you'll see the output that Anthony mentioned before. This is all the things that the build pack has set at runtime. And there's the app started. Okay, so that's the pack CLI. Let's take a look at the same app built with the Spring Boot Maven plugin. So this is sorry, next slide.
Sorry.
Yeah, here we go. Okay, so this is the same app, and we've enabled the Spring Boot Maven plugin in the POM, and we can run the Spring Boot build image command. So this will build the jar within Maven, and then the plugin will hand the jar over to Buildpacks to run the detection and build phases again. So we can see the output that we've seen before. This time is just all within the Maven build. So we'll build our image, and we can do Docker run just to see it start up the same way. Okay, there we go. So let's go back to Anthony to talk through some of the advantages specific to Java that you get with Paketo Buildpacks.
Yes, thanks, David. That's right. The Paketo, the Java family of Paketo Buildpacks includes several individual buildpacks. And let's talk about what they can do for you. First of all, you can customize, of course, your Java version, and it's pretty easy to do. So you just specify the BP JVM version. For example, 24 was out just this month of March, and you can already use it. It's already provided to you. By default, the Paketo Buildpacks always include in a Java build the Bersoft Liberica OpenJDK implementation. So this is their Jerry and JDK that we're using, but you can switch vendor pretty easily. You just need to mention your favorite vendor. So here, for example, you could use Microsoft OpenJDK, but we also include JVM from Amazon Corretto, Azul, Zulu, and so on and so forth. I already mentioned earlier on that we also include a memory calculator. So it's a binary that basically will understand your application and also your environment to better set your JVM arguments. So that's pretty convenient, because whenever your app starts, it will run and it will make sure that all the JVM arguments provided to you are going to take the best of your environment. Also, we have a bunch of Spring Boot optimizations that have been added recently to the Spring Boot build pack. So David, you already mentioned the Spring Cloud bindings. That is basically injecting a library that knows about the different third-party services that we need to configure your app with. But also there is, so this is one of the recent feature, class data sharing training run, the CDS training run. So after your application is built, we can actually do a training run with CDS, so that it's going to be a limited run. And during this limited run, we will load all the classes and put them basically in a caching file. And then we'll make sure that this caching file is included at runtime. And of course, it's going to save you time and memory. Also, a very nice feature from the Spring Boot Buildpack is Spring Generation. It allows you to emit warning to the developer if they are using a deprecated version of Spring Boot. So basically, at build time, you will have some information about whether or not your Spring Boot version is supported. Okay, so let's see those in action. This time, we'll take an already built project, Spring Resbugs from Oliver Drodbaum. And this project is kind of interesting because this is a full-blown app that interacts with a database, actually. Okay, so here in this application code, you can see that it's built with Maven. And we have a profile that is named Buildpacks. And inside this profile, since we are using the Spring Boot Maven plugin, we can actually customize the behavior. As you can see here, we are taking a builder that is based on Ubuntu Noble. And also we have specified a build pack that is from another vendor, which is Adoption. As well as the version, we said 24, and also we have enabled some Spring optimization, such as CDS and AOT. Thanks to that, during the build, that was, to be honest, pretty quick, the training run happened and we generated this CDS caching file. So as you can see, the app is starting under less than a second, so it's pretty fast. And also at runtime, the Buildpack made sure to include the information, as you can see here, that allows the JVM to load those optimizations. Now let's look at another profile that is included in this project, the Buildpacks native profile. And as you may guess, this one is going to be based on GraalVM. By default, we're going to use the Paketo Buildpacks are going to use Liberica native image kit, NIC, version 24. And also, as you can see, we have a BP native image environment variable that is being provided. Also, it's worth noticing that the NIC that we're downloading from Bearsoft is based on ARM64 because the laptop that was used during this demonstration is a MacBook M4 laptop, so based on ARM. And ARM is fully supported across the Java Buildpacks. Of course, native is super efficient, but it also requires you, the developer, to find out some hints. So here it was done for you by Oliver. But yeah, just to say that native is kind of impressive, but it takes a long time compiling. And also sometimes you need to find out those hints by yourself. So this is fast, but that's not also a silver bullet. I just wanted to mention that. When you start up, then yeah, you get even faster startup time with 200 milliseconds this time. Sorry. So now a question that you may wonder is, okay, Buildpacks are great. Okay, not sure what's happening here. Sorry about it. So Buildpacks are great. How do you integrate them to your existing pipeline? Well, for example, if you're already a Spring or Gradle shop, then it's kind of easy. You already got those plugins in place for you that were already demoed. Even from Quarkus, I think there's early support. If you are building using Kubernetes, then you could actually use Kpack. Kpack is basically a tool. So it's based on it's using custom resource definition where you would actually create a manifest. And in this manifest, you would give the URL of the source code to check out, as well as the builders and Buildpack to participate. And then Kpack would organize this, would understand this, and pull the different Buildpacks and builders to create your OCI image. You can also rely on your favorite CI tools, such as GitHub Actions, GitHub CI/CD, and Jenkins. They all provide integrations with the Buildpacks, and they are official ones, actually. But if you want your platform as a service provider to build the image for you, well, you're in luck. Because Fly.io and Porter, for example, they both support the Docker file, but they also support the Buildpacks and even the Paketo Buildpacks implementation by default. So basically, you just give your source code to their tool, and then they're going to build it for you using their own builders. Heroku, of course, they are using their own implementation of cloud native Buildpacks, but you could also use the Paketo Buildpack if you prefer, since they are part of the same specification. They implement the same spec. Finally, we wanted to mention the cloud providers. Here, for example, with Google Cloud, there is the offering from the Cloud Run, from Cloud Run service, where it's kind of also it loads your source code and then going to build your application using their own implementation of the Buildpack. Once again, you could use the Paketo Buildpacks if you want to. And finally, Azure Container Apps, which replaces the now deprecated Azure Spring App and Azure Spring App Enterprise. So how does that work with Azure Container App? Same thing, once again, you just give your source code to Azure Container App, and then they're going to use Buildpacks, which are Paketo. Some of them are Paketo Buildpacks, and some of them are Azure maintained Buildpacks as well. So just wanted to say that when you're switching to Buildpacks, you won't be alone. There are a whole ecosystem of users and providers of Buildpacks. Now it's the end. Thank you very much for attending this session. You can take a picture of this QR code to have links to all the documents, all the documentation for Buildpack, and also the examples that we used. Thank you for being there with us, and enjoy the rest of the conference. Bye.
Thank you.
Oh, I hope everyone feels really empowered to not only take the career forward, but also we were privileged to have speakers. We were privileged to have thousands of developers with us here. I want to thank all the speakers and our viewers. We had so many incredible sessions today. Now, understand, if you missed a session, everything's on demand. So you can go in there, you can watch those sessions, give it a like, subscribe to our channel. You really want to go and watch some of those sessions. Remember, we had the Americas. This is the Asia Pacific. And tomorrow, a little bit later, actually, not tomorrow, we've got the EMEA section. And Sandra, my colleague, is going to be the host. And there's even more awesomeness that they're going to do. Now, how do you get involved? How do you actually make sure that your voice is heard here? We have a survey. We really want you to take the survey here. Feedback for the event. You can get hold of some of our product teams. You like what Nick showed with that upgrade wizard? Guess what? You can pop it there saying, hey, I'm a customer. I would like to be contacted with that. You go all of that. Do that survey here. Thank you to our speakers. Everything's available on demand. And stay tuned for the EMEA and Sandra, and take the survey and carry on with your learning. I'm Rory Preddy, Principal Cloud Advocate for Microsoft, and I thank you for spending time with us, and we'll see you a little bit later for the European time zone. Cheers, everyone.